to the channel. Today on this video, as you can see there on the screen, we'll be doing the National Certificate Mathematics N5. This paper was actually written on the 25th of November 2025. It was an X paper and it took about 3 hours. So on this video, we're going to start with question 1, and then we're going to continue with question 2, question 3, question 4, and question 6. So I'm going to leave the timestamps for each and every question that you would like to watch if you don't want to watch this question paper in a sequence order. All right, guys. So before we start though, if you are watching these videos on this channel for the first time, do not forget to like, share, comment, and subscribe to the channel. Now that we are done with the intro, how about you look at question 1 of this question paper? All right, here's our question 1 here. This question 1 consists of only 2 questions, guys. So I'm gonna create a space and solve this question 1. So let's create the space and let's solve 1.1. All right, so here is our 1.1. The question goes like this: determine the following limit. Before we start with this question, as you can see, we have y is equaling to limit x approaches 0. We have the numerator where we have 3x squared plus e. All this is divided by 2x cubed plus 5x. So we first start by doing direct substitution with this one. So wherever there is x, we're going to substitute with 0 since x is approaching 0. So let's do it. So it's going to be 3. Instead of writing x, we're going to write 0 squared plus e to the power of 0 instead of writing x, right? Divide by 2. And then wherever there is x, we put 0 to the power of 3 plus 5 multiplied by 0, right? So if you continue, on the numerator, we're going to have 0 plus 1 because 3 multiplied by 0 to the power of 2, that is going to be 0. And e to the power of 0 is going to be 1. So anything to the power of 0, guys, it's 1. Divide by 0 plus 0, right? And all this is more like 1 divided by 0, which is, this is going to give us infinity. So if it gives us infinity like this, it means that we need to do the following step. So simplification, it won't help here. Dividing with x with the highest power also, it won't help here. So we need to apply the L'Hopital rule. Your question must be a fraction. As you can see, this is a fraction. We are fine with that. And we have to get infinity when we do direct substitution. Now that those 2 terms are met, now with L'Hopital, what you should do is you must differentiate the numerator and the denominator. So let's continue. Y is equaling to limit x approaches 0. Let's not forget that. Now what we need to do here is to differentiate the numerator and the denominator. Now if you look at the numerator, the first term with 3x squared, the standard differentiation, this is going to give us 6x and then plus e to the power of x. When you differentiate e to the power of x, that's going to give you e to the power of x. It's an exponential differentiation. And then on the denominator, we have to differentiate 2 multiplied by x cubed. This is going to give us 6x squared plus 5. If you differentiate 5x there. Now, after differentiating, we do direct substitution. Let's do direct substitution. If we substitute x with 0, remember x is approaching 0, this is what you're going to have there, right? Divide by 6 multiplied by 0 squared plus 5. If you continue, on the numerator, we have 6 multiplied by 0. That is going to give us 0 plus e to the power of 0. That is going to give us 1. Divide by. There we go. And then we have 6 multiplied by 0 squared. That is going to give us 0 plus 5. So our final answer here is actually 1 over 5. So that is going to be our limit. So the limit here is actually 1 over 5. So guys, just in case you didn't understand how to differentiate, there are videos that I made explaining the standard differentiation. So just in case you didn't understand, you can always leave a comment on the comment section. Even if you understood, you can also leave the comment as well. If this video really helped you, do not forget to like, share, and if you haven't subscribed, subscribe to the channel. All right, people, we are done with 1.1. We're going to do 1.2. All right, guys, here is our 1.2. Now, 1.2, we have the statement there. They want us to determine the values of x in the domain 0 to 360 degrees for which f of x is discontinuous if f of x is equaling to sec x. First of all, we need to change our f of x here. Let's change it. Our f of x, we can say 1 over cos x. This is what we call the inverses. Just in case you don't know much about inverses, you can go to the description. I will leave a link there about the inverses, and also the very same video about the inverses is going to pop up on the top right of this video. Go and watch those inverses. So our f of x, now we have a fraction, which is good. Now we need to find the value of x, which is going to give us 0 when we substitute to cos them. So it's simple. What you need to do here, you say cos x is equaling to 0. So the denominator, you equate it to 0, right? Then from there, you solve for x. This is so simple, guys. You're going to transpose our cos to the right-hand side. When you transpose our cos to the right-hand side, it's going to become arc cos 0. Guys, arc cos 0, it is not cos to the power of -1. You press shift, then you press cos, then you will have arc cos 0. So arc cos 0, I am getting 90 degrees. Now, 90 degrees is not the only one that we're supposed to get. Remember, our domain is given to us from 0 to 360. So if you look at our cast diagram, 270 and 360, right? So if you look at this one here, our denominator, which is cos, the cos is positive. So this is how you're supposed to do it. Here is theta. On the first quadrant, cos is positive. And also on the fourth quadrant, cos is positive. So we're going to only focus on these two quadrants in order for us to get the right x values. So for the first quadrant, we are fine. We have 90. That is our final answer. And then for the fourth quadrant, we can say x is equaling to 360 minus 90. So 360 minus 90 is supposed to give us 270. Let me just create a little bit of space here. So x is going to be 270 degrees. So these two are the answers there. So in order for this f of x to be discontinuous, our x is supposed to be 90 and 270. If we do substitute 1 over cos 90 or 1 over cos 270, we're going to get infinity for both of them. Infinity for both of them. This means that 90 and 270 are the values where our function is discontinuous. I hope you guys managed to understand this. It's really not that difficult. What you need to do here, you must first have a fraction, and then the denominator you equate it to 0 and you solve for x values. That's it. Okay, people, this is the end of question 1. So if you have any questions, you can leave a comment on the comment section. If you don't, you can also leave a comment on the comment section. You can always like, share the videos, subscribe to the channel if you haven't subscribed. I'm going to do question 2 of this question paper. Now here is our question 2. Question 2 is actually derivatives. So consists of 20 marks. Okay, so let's go and do question 2.1. So let's read the question. So question goes like this here. Determine dy over dx in each of the following cases. And the following instruction is given here. Simplification not required, meaning when we differentiate these questions here, we don't need to simplify. You just differentiate it once. All right, let's look at 2.1.1. Now, as you can see, this question here, it's a chain rule. So they want us to differentiate this. So as you can see, we have a function within a function within a function. So it's a chain rule. So let's identify these functions here. So let's start with the whole equation. So we have this one here. I'm gonna highlight with blue. It's everything, including the power there. Okay. So the one that is in blue, it's everything that is include the power. Then let's look at the lean. So we have one for lean. Let me highlight with green. I hope you guys can see this. Okay. And then we have the one inside there, which is all of this inside the bracket there. So we actually have to derive all these. So as you can see, we also have an expression that has a root there. We need to change that. So before we differentiate, how about we simplify first? So we're going to have lean to the power of 3. Open bracket, we have x squared minus 5x plus, and then instead of writing the root, we can put it inside the bracket and write the exponent. So what is the exponent in terms of root? We know that is the power of half. And then we close the bracket. So when it's like this, it's easy for us to differentiate. Again, let's highlight our functions there. We have lean to the power of 3. Let me highlight very quickly. And then we have lean. Let me highlight with green there. And then we have the inner part there. There we go. So what we have to do here, guys, is we need to differentiate each and every expression that you see there, and we multiply them. So let's start with the one with lean to the power of 3, right? dy over dx, right? Now this one is the same as when you have f of x to the power of n, right? When you differentiate this, this is going to give you n f of x n minus 1. There we go. So our f of x here, it's actually lean 3 with everything inside there. So let's do it. So if we use this, remember this is 3. So that 3 is going to be there. As you can see, that is n there. And then we multiply with f of x. So f of x, which is lean. This time around, we say lean 3 minus 1. So this is going to give us 2 there. There we go. And then you write everything inside there, guys. It's going to be x squared minus 5x plus, and then open bracket, x squared minus 7 plus 20 to the power of half. You close the bracket because you have these brackets there. There we go. Then we are done with the one in blue. Now let's do the one in green. Now the one in green, the one that I highlighted in green, is just a differentiation of lean x, right? Instead of x, in fact, we have everything that is inside there, which is x squared minus 5x plus, open bracket, x squared minus 7x plus 20, close bracket, to the power of half. The derivative of lean x, we know that it's going to be 1 over x. But instead of writing 1 over x, remember we have to multiply by it. It's going to be 1, right? Divided by everything that is inside there, which is going to be x squared minus 5x plus, open bracket, x squared minus 7x plus 20 to the power of half. There we go. So this is the one in green there. There we go. Let me just create a line here. I hope you guys can see, right? Then we are done. Now let's differentiate the one in red, the one inside lean there. As you can see there, we have individual terms, and also we have the one with the power of half. So let's start with the x squared there. So you have to open the bracket. When you differentiate f squared, it's going to be 2x, right? Minus 5, because the differentiation of 5x is 5 plus. Then inside there, remember we have open bracket, x squared minus 7x plus 20 to the power of half. So we have to use this formula again because we have f of x to the power of n, which is half there. When you derive it, we must multiply by n, which is our half there. So it's going to be half. There we go. Multiply by everything that is inside there. So it's going to be x squared minus 7x plus 20. There we go. To the power of, remember, if we use this formula, we know that it's going to be n minus 1. So our n here, which was half minus 1, is going to be negative 1 over 2. Then we multiply by the derivative of the expression that is inside here. We have x squared minus 7x plus 20. So we have to derive that. So derivative of x squared is 2x. The derivative of 7x is going to be 7 there. 20 is 0. So this is basically how you derive this. Remember, they say do not simplify, but you can if you want to, which is not necessary. Let me just do it to make our life easier. So this here is going to be 3 ln 2, and then we write everything that is inside there, x squared minus 5x plus, open bracket, x squared minus 7x plus 20 to the power of half. There we go. And then close bracket. Multiply by 1 over this one here. So if you multiply by 1 over, let's do it this way. Multiply by 1 over x squared minus 5x plus, open bracket, x squared minus 7x plus 20 to the power of half. There we go. Multiply by everything here. So inside there, let's not forget to put the bracket. So we're going to start with this one here, which is 2x minus 5, right? Plus half. There we go. But instead of writing this x squared minus 7x plus 20 to the power of negative half, we're going to change this, the power of negative half, into a positive. So what we're going to do is we're going to continue multiply by 2x minus 7. So it's going to be multiply by 2x minus 7. And then all this is going to be divided by x squared minus 7x plus 20 to the power of positive half, because we changed that into a positive exponent. So the denominator become a numerator become a denominator. So we close the bracket there. So this is our final answer. Don't simplify it further, people. In fact, here it's fine. But if you wanted to simplify it further, this was going to be okay. So this is how you differentiate this type of a problem. It's a chain rule, guys. So you differentiate the outer part, which is ln to the power of 3, which is this one here, right? Differentiate it there. And then you must differentiate the ln on its own, which is this one here that I highlighted with green there. And then you must differentiate to what is inside ln there, which is all of this. All of this. There we go. So I hope you can able to see that, guys, because this is a bit challenging, especially if you're not familiar with chain rule. But anyway, I hope you managed to understand. If you did not understand, leave a comment or watch at the point where you got lost. If that doesn't help, you can leave a comment. If this video helped you to understand how to derive this type of problems, don't forget to like, share the video, subscribe to the channel if you haven't subscribed to the channel. All right, people, we are done with this question 2.1.1. Let's go into question 2.1.2. All right, here is our 2.1.2. Now, they want us to differentiate this expression that you see here. As you can see, we have inverses of trigonometric ratio. We have the inverse of sec and the inverse of tan. Now, you need to know these derivatives. They are there on your formula sheet. For arc sec, for example, for arc sec x, it is written like this in a formula sheet, dy over dx. It's supposed to give you 1 over x root x squared minus 1. All right, you can also write it like this, arc sec f of x. Instead of writing x, you substitute with f of x. Then when we derive this one, it's going to be dy over dx. Okay, we're going to have f of x prime on the numerator. Instead of writing this one, it's f of x prime divided by. Now, instead of writing x, remember we write f of x there. And then root. Then we're going to have f of x, let's not forget, squared there, minus 1. There we go. So if we derive using this here, I prefer to use this one here. Guys, it's the same, just in case you get confused with this one here. If we derive using the one underneath there, arc sec f of x, it means our f of x here, it's actually x squared, this one here. It's our f of x. There we go. So the derivative here, dy over dx, is as follow. We say we have the derivative of f of x, which is on the numerator there. So it's going to be 2x. Remember our f of x here, it's actually x squared, right? Divide by, right? So let's look at this. We have f of x there. Our f of x, we said it's x squared. So we're going to write x squared there. And then root, right? Then what is inside the root? We have f of x squared. So our f of x is x squared. So we're going to have x squared minus 1. So we have 1 there, right? So this is the derivative, right? Plus. Now let's look at the derivative of arctan. Now the derivative of arctan, if you go to the formula sheet, it's going to be as follow. It's 1 over 1 plus x squared. There we go. Or we can write in this manner, arctan. Instead of writing x, we can write f of x there. And then when we derive this, dy over dx, it's going to be divided by 1 plus f of x, but squared. There we go. So this is how you're going to do this one there for tan. Now let's look at our f of x. As you can see, our f of x for tan there, it's actually 1 minus x over 1 plus x. This on its own, it's actually the quotient rule. Now, the quotient rule, we have a formula for it. Remember, when you derive the quotient rule, you need to derive the one on the numerator first, and then you multiply by the one on the denominator. Then you subtract, and then this time around, you derive the one on the denominator, you multiply by the one on the numerator. Then all of this is going to be divided by the denominator square. So our f of x, like we said, it is this one. So let's derive our f of x. 1 minus x divided by 1 plus x. You can start with the one on the numerator. The derivative on the numerator, we know that is going to be negative 1, right? Multiply by 1 plus x. So if we derive 1 minus x, it's going to be negative 1. Multiply by 1 plus x, then minus. We leave the 1 on the numerator, which is 1 minus x there. Multiply by the derivative of the denominator, it's 1 plus x, which is going to be multiplied by 1. Okay. Then we divide there. We divide by 1 plus x. Then close bracket, we square them. This is a quotient rule, guys. Just in case you don't know it, you can go to the description. I'm going to leave a video where I explain the quotient rule. And also the very same video will pop up on the top right of this one that you're watching. All right, so let's continue. We are not done. We are done with f of x prime, this one here. Now it's time for us to multiply by 1 over 1 plus our f of x. Remember this one here or that one here. It's 1 minus x divided by 1 plus x. But let's not forget, we need to square it based on this here. So this is the derivative of the question that we have there, 2.1.2. All right, we are done with 2.1.2. Let's go and do the next question, which is 2.2. All right, guys, let's look at 2.2. Now, 2.2, they want us to calculate the dy over dx if we are given y, which is equaling to 3 to the power of x ln x squared with aid of logarithmic differentiation. So we need to use log to differentiate this. First of all, we need to introduce log both sides. So we have y is equaling to 3 to the power of x ln x squared. If we introduce log on the left hand side, we're going to have ln y, right, equaling to. What you do on the left hand side, you must also do on the right hand side. So we're going to have the following there. There we go. So some people might get confused. Ln is already there, but as you can see, it's there as an exponent. It's not there as a base. So we have to introduce ln when it's like this. From here, let's simplify. So on the left hand side, we have ln y there. And then On the right hand side, if you simplify, we can take this exponent there to the front. There we go. Now let's do it. We can say x ln x squared multiplied by ln 3. There we go. This is a rule. When you have ln x to the power of 2, you can use this rule here. You can take 2 to the front. You'll be left with 2. Then ln x. That is a rule for logs. I hope you guys know about these rules here. So that's what we did here. All right, so this is it. As you can see here, we have two functions that are multiplying each other. We have x and we also have ln x squared. These are two functions multiplying each other, multiplying the coefficient, which is ln 3 there. So let's continue. So we have to differentiate this. So when you differentiate any function that has y, it's a implicit. So let's do it. So it's going to be dy over dx, remember, multiplied by 1 over y. The derivative of ln y, it's 1 over y. But let's not forget, we are deriving with respect to y. We have to multiply by dy over dx, then equaling to. Now ln 3, it's a coefficient. You can write it on the side there, then open bracket. Then you apply the product rule. Guys, this is a product rule. X multiplied by ln x squared. That is a product rule. So I can write this as f of x, and then this one is g of x. There we go. I hope you guys understand this, right? So let's derive our f of x. Our f of x is 1. So it's going to be 1 multiplied by ln x squared. There we go. Plus. Now the second one, we derive g of x. Let's start by writing our f of x here. And then our g of x, we start with ln. When we derive ln, it's 1 over x squared multiplied by. Now, let's derive our x squared there. It's going to be 2x there. Then close bracket like that. Right, let's continue. Dy over dx, right, multiplied by 1 over y. We have ln 3 there, and then multiply everything that is inside there. So the first term here is 1 multiplied by ln x squared. So this is just going to be ln x squared, right? And then our second term, we have plus them. We have x squared dividing x and that x there multiplied by 1. So this is going to be 2 there. Now if you continue, we're going to have the following: dy over dx, right, multiplied by 1 over y. We remove the brackets. We're going to have the following here: ln 3 multiplied by ln x squared plus 2 ln 3. There we go. But we're not done. We have to cross multiply this y there. So the final answer is going to be dy over dx. This is equaling to y, and then open bracket, we have ln 3 multiplied by ln x squared plus 2 ln 3, close bracket. But we are not done. Remember, y is equaling to our original expression there. So let's do it. So dy over dx is actually equaling to 3 to the power of x ln x squared, open bracket, ln 3 multiplied by ln x squared plus 2 ln 3, close bracket. So this here, guys, is our final answer. Okay, some of you can continue and do it this way: 3 to the power of x ln x squared, open bracket, and then we can take this 2 to the front. Okay, let's take it to the front. We're going to have 2 multiplied by ln 3 plus 2 ln 3. Okay, you can take out the common factor here, which is 2 ln 3. So you can write it as 2 ln 3 multiplied by 3 to the power of x ln x squared, open bracket. So if you take out this one here, we're going to be left with ln x there plus 1. So this can be your answer as well. But people, you can stop here or there. It's really up to you guys. So this is how you do this one. Just in case you didn't understand, again, you'll have to rewatch at the point where you get lost. And if that doesn't help, you can always leave a comment on the comment section. Guys, most of these derivatives, we have done them on N4. That's why I don't dwell on them that much. If you don't know how to do a log derivative, I will leave a video that is based on natural log derivatives. And also we have a chain rule there and a product rule as well. So I hope you were able to see how to derive these two rules here. Okay, people, thank you very much for watching. If this video helped you to understand, do not forget to like, share, and also subscribe to the channel if you haven't subscribed. We are done with 2.2. Let's go and do 2.3. Here is our 2.3. Now we're going to start with 2.3.1, but let's see what is it that we're supposed to do here. As you can see from 2.3, there's a given the implicit function. So meaning we need to do implicit here. We have x squared multiplied by y plus cos, open bracket, pi over 2 multiplied by y, close bracket, minus 4x squared is equal to 5. So this is an implicit. So they want us to find dy over dx. So let's continue. We have the first term here. We have x squared plus y. This is a product rule, guys. Again, you have to use the product rule. Now, if you use the product rule for this one, let me open the bracket. We're going to derive x first. So we're going to have 2x. There we go. Because x squared, the derivative of x squared is 2x multiplied by y. Right. Then plus. Now, this time around, we leave that x squared. We derive y. When we derive in terms of y, we know that we're going to have dy over dx. There we go. Then close bracket, plus. Now let's look at cos. Now cos, we have cos pi over 2y. Now we need to derive this. So if we derive cos, if you go to the formula sheet, you know that we have to multiply by the coefficient. What is our coefficient there? It's pi over 2 then. Now the derivative of cos, we know that it's going to be negative sine pi over 2y there, right? Close bracket. Since we are deriving cos in terms of y, let's not forget we multiply by dy over dx. There we go. Minus. And then we have negative 4x squared. So this is going to be 8x. All this is equal to 5. What is the derivative of 5, which is a constant? It's going to be 0. Then from here, we need to group all the terms with dy over dx together and the terms that does not have dy over dx. Let's first remove the bracket and multiply by negative there. If you remove the bracket, we're going to have 2xy plus x squared multiplied by dy over dx. There we go. Minus, because we have this minus here, right? Pi over 2 sine pi over 2y multiplied by dy over dx minus 8x. All this is equal to 0. From there, we're going to transpose these terms here because they do not have dy over dx then to the right hand side. So we're going to be left with x squared multiplied by dy over dx, right? Minus pi over 2 sine pi over 2 multiplied by y there, multiplied by dy over dx. Right, so let's transpose these terms here. If we take this negative 8x, this is going to be positive 8x. If we transpose this positive 2xy, this is going to be negative 2xy. So as you can see, on the left hand side, we're left with terms that has dy over dx. So dy over dx is a common factor here. We take it out, dy over dx. On this term here, we want to be only left with x squared. X squared. On this term here, we're going to be left with negative pi over 2 sine pi over 2 multiplied by y there. Close bracket. And all this is equaling to 8x minus 2xy. Right. So let's create space, guys. We have to divide by all of x squared minus pi over 2 sine pi over 2y. So we have to divide by all of this. We have to divide by all of that. So if we divide on the left hand side, we're going to be left with dy over dx. On the right hand side, we're going to have 8x minus 2xy divided by x squared minus pi over 2 sine pi over 2y. There we go. So this here is our answer for the question here, which was 2.3.1. So we are done with this one. Again, guys, this was implicit. Just in case you don't know much about implicit, this is how you do implicit, guys. So we are done with this question. If you didn't understand, you can rewatch at the point where you get lost. And if you have a question, you can leave the question on the comments. But if this video helped you to understand how to derive such questions, do not forget to leave a like and also subscribe to the channel if you haven't subscribed. Share the videos to your friends. We're done with 2.3.1. Let's do the last question, which is 2.3.2. As you can see, I didn't erase the first workout of 2.3.1 because this question here, 2.3.2, it needs us to use the equations or the expression that we just got them. So let's read the question. The question goes like this: determine the equation of the tangent of the graph of the point x is 1, y is 2. So guys, what we have to do here is to substitute our values on our expression that we got them. So I'm gonna do it here on top where we have dy over dx. Then wherever there is y and x, we're gonna substitute with these values here that we have them. Right, so our expression there, we have 8x. Instead of writing x, we're gonna write 1 there, right? Minus 2x multiplied by y. So instead of writing x, we're gonna write 1, and then instead of writing y, we're gonna write 2 there, divide by. So this is where things get tricky. Let's start with the first term on the denominator. X is 1, so it's gonna be x squared, which is 1 squared there. Now minus this one here, it's pi over 2. There we go. Then it's sine. Instead of writing pi over 2, guys, as an angle, you can write it as 90 degrees. Remember, pi over 2 multiplied by 180 divided by pi. This here is the same as 90 degrees. You can write it as 90 degrees. If you decide not to use the rads on your calculator, right? So I will write it as 90 degrees multiplied by y. What is our y in this case? It's gonna be 2. There we go. Then you put this on your calculator. Let's put it on our calculator. Dy over dx. If you put it inside the calculator, our final answer here is gonna be 4 on the numerator divided by 1 minus 0. So the final answer, dy over dx, is actually 4. There we go. All right, so from here, what you should do is to determine the equation of the tangent. Guys, a tangent, it's a line that touches a circle once. So that's a tangent. So the equation of a tangent, it's the equation of a straight line. So we know that we have this formula, y is equaling to m, which is the gradient, x plus c. What you should know is that dy over dx is equaling to the m, which is our gradient. So this here is the same as m, that for them. So if we do have the gradient and we have x and y, we can find c. So y, based on our point there, is going to be 2, is equaling to 4. 4, which is our gradient, multiplied by 1, which is the coordinate of that point there, plus c. There we go. So if we continue, we have 2 is equaling to 4 plus c. So c is equaling to negative 2. There we go. So the equation of this here, let's create space, guys. The equation of this expression, it's as follows. It's going to be y is equaling to our m, which is 4, the gradient, multiplied by x minus 2. So here is our equation here, guys. I hope you managed to understand how to do this one as well. It was not difficult, but it needed you to understand how to find the equation of a straight line, because the tangent is actually a straight line. just in case you didn't understand, you can rewatch at the point where you got lost. And if that doesn't help, you can always leave a comment there. But if this helped you guys to understand, do not forget to like, share, subscribe to the channel if you haven't subscribed to the channel. We are done with question 2. Here is our question 3. As you can see, question 3, it consists of 20 marks. So it has lots of questions here. So we're going to start with 3.1 and then we're going to do other questions later on. So let's create some space and let's solve 3.1. All right, here's our question 3.1. 3.1 also has question 3.1.1. So let's look at this question here. First of all, we are given the following, the function there, f of x is equal to x cubed minus 3x plus 5. So this is the function that we'll be working with 3.1. So 3.1.1, they want us to determine the coordinate of the turning point. Now this here is a cubic graph, guys. For the fact that it has x to the power of 3, it means that it is a cubic graph. So now they want you to calculate the turning point. So when you calculate the turning point, this means that you need to derive this function that is given to us and equate it to 0. All right, so let's find the coordinate. So first of all, we derive this. So when you derive this, it's going to be f of x prime is equal to the derivative of x to the power of 3 is going to be 3x to the power of 2 minus 3. All this is equal to 0. Do not forget, guys, whenever you are calculating the coordinate of the turning point, when you derive, you will always equate it to 0. So since it's like this, we can transpose this negative 3 to the right hand side. So we're going to be left with 3x squared is equal to, if we transpose this negative 3 to the right hand side, it's going to become positive 3. And then we divide by 3 throughout them. There we go. So x squared is equal to 1. But now we are not looking for x squared. We're actually looking for x. So we have to square root both sides here to get rid of the square there. So the square root of x squared is going to be x. And then the square root of 1 is going to be plus or minus 1. There we go. So this is the x coordinate of the turning point. One is positive and the other one is negative. So we need to find the y coordinate of the turning point. So you can say when x is equal to positive 1, what is your y? So you need to find y there. It's very, very simple, guys. All you have to do is substitute this x value, which is equal to 1, to the original equation there. So we can say y is equal to, so as you can see, our original equation, we have x to the power of 3. Instead of writing x, we're going to write 1 there to the power of 3 minus 3 multiplied by x. But this time around, we're going to say 3 multiplied by 1 plus 5. So you put this on a calculator and then you'll get your answer. So if you put this on our calculator, our answer here is going to be 3. There we go. When x is 1, our y is going to be 3. Now we can call this turning point 1. When x is 1 and then y is going to be 3. Right. So how about when x is equal to negative 1? What is our y? There we go. What is our y? There's a question mark there. So we're going to do similar with what we did before. We're going to take the original equation and this time around we substitute negative 1 wherever there is x. So let's do it. Y is going to be equal to, now open bracket, negative 1. Then we have cube there, minus 3 multiplied by negative 1 plus 5. Now you have to put this on a calculator. If you put this on a calculator, your y is going to be 7. So turning point 2, here we go. When x is negative 1, y is going to be 7. So this here is our answer. So we have 2 turning points there. Remember, they want us to find the coordinates of the turning point. I hope you guys managed to understand this. Really, it was not that difficult to do. Just in case you find it to be difficult or you got confused somewhere, you can go and rewatch at the point where you got confused. And if that doesn't help, you can always leave a comment in the comment section, ask a question. But if this part of the video help you to understand how to calculate the turning point on the cubic graph, you can always like the video, share the video, and if you haven't subscribed to the channel, subscribe to the channel. All right, people, we are done with 3.1.1. How about we do 3.1.2? All right, here is our question, 3.1.2. Now, let's see, what is it that they want from this question? They want us to draw up a table of x and f of x, where x is ranging from x is equaling to -3 to x is equaling to 2. So basically here, they want us to draw a table from -3 to +2 on the x-axis. So let me just draw the table and then let's insert the values there. All right, so here is our table. Remember, they said it should be from -3 to +2. As you can see, it's starting from -3 to +2. I hope you can see that. So what you need to do here is to substitute the values of x on the original equation. So here's our original equation here. F of x is equaling to x cubed minus 3x plus 5. So basically what you do here is you substitute these x values here on the original equation. Whatever you get, you insert underneath on f of x box there. So let's start with when x is equaling to -3. So if x is equaling to -3, you have to substitute it here on the original equation, and then you will get your f of x. So let's do it. Let's use our calculator. So when I substitute -3, I'm getting -13. There we go. Now let's go to the next one. When x is -2, when you substitute it here on the original equation, what do we get there? I'm getting a 3. There we go. Now let's go and do -1. When x is -1, what do you get there? I'm actually getting 7, right? And then when x is 0, what do we get there? I am getting 5. When x is 1, what is it that I'm getting there? I'm getting 3. And then the last but not least, when x is +2, what am I getting? I am getting 7 there as our f of x. There we go. So guys, basically this is what they wanted you to do. We are done with this question, guys. I don't think this question was difficult for you, but just in case, again, you didn't understand, you can leave a question on the comments. And if you did understand, you can also like the video, share the video, and also don't forget to subscribe to the channel, share this video to your friends, and don't forget to hit the bell notification as well. Now let's go and do the next question, which is 3.1.3. All right, guys, here is our question, 3.1.3. Now let's look at this question here. As you can see, here's our question there. Now they want us here to draw a neat graph of f of x between these values, showing the turning point on it. So we're gonna use this table that we just did to draw our graph. Also, we need to show our turning point that we got earlier on this question here, which is question 3.1.1. So let's draw our graph. So I'm gonna draw the graph on the right hand side here. Let me first draw the Cartesian plane. All right, so here is our Cartesian plane, guys. So let's draw this graph using the table that we did earlier on 3.1.2. All right, so let's start with the first point here. The first point goes like this. X is -3 and f of x in this case is the same as y. It's -13. -13, it's somewhere close to -12 here. So I can say at this point here, this is our -13 there. And then our x is going to be -3. So I have to draw a line there. And our x is here, which is going to be -3. So make sure that you don't draw a very visible line, only fainted lines like this. Wherever they intercept, that is your point there. So this is my point here. We have the second point here where x is -2 and y it's +3. So as you can see, -2, there we go, Here's our negative 2 there. And our y is positive 3. So if you take a ruler, a driving line, this here is going to be our point. There we go. And then we go to this point here where x is negative 1 and y is 7. So negative 1 is this one here. You can draw a line that is going upwards. There we go. Now y is going to be positive 7. So since we don't have 7 on our y-axis, we can assume that 7 is a little bit above this point here. There we go. At this point here, we can say our x is negative 1 and our y is 7. Now let's continue. So as you continue here, this is the next point. Our x is 0 and our y is 5. So x is 0 on the y-axis. We are fine there. And then our y, it's 5. So 5 is way below this 6 here. So we can put it somewhere there. You can say this is 5. There we go. Now let's do this point here where x is 1 and y is 3. Now we're going to draw a line here on 1. Let's do it. There we go. And then also 3, we're going to draw a line that is horizontal as well here. So this here is going to be our point there. As you can see, this is also our turning point. I almost forgot about our turning point. This is also our turning point there. And then the last point here where x is 2 and f of x is 7 or y is 7. So we draw a line that is going vertical like that, which is 2. And 7 is supposed to be somewhere here as well. Draw a line that goes like this. Say this is 7 there. So let's connect the dot. So here is our graph. Remember, we need to write the turning point. Let's start with this one here. This turning point here, x is negative 1 and then y is 7. This one here, x is positive 1 and then y is 3. There we go. So do not forget to write these turning points. As for other points, even if you don't indicate them, it's still fine. Right. I hope you guys managed to see how we draw this graph. It was not that difficult. Again, people, it required you to know how to do the table for you to draw this graph. Just in case you got confused on how to draw this graph, you can always leave a comment on the comment section or rewatch at the point where you got lost. And if that doesn't help, leave a comment. If this part of the video helps you to understand how to draw this type of a graph with this method, do not forget to like, share, and also comment on the comment section. And if you haven't subscribed to the channel, subscribe to the channel. We are done with 3.1.3. Let's go and do 3.1.4. All right, guys, here's our 3.1.4. Now we have a statement here. Let's read the statement and analyze this question. So the question goes like this. Given that x is equaling to negative 2,3, it's an approximate root of the equation x cubed minus 3x plus 5 is equaling to 0. Use Taylor's method or Newton's method to determine a better first and second approximation of this root. Open bracket, root correct to 3 decimal figures, close bracket. Guys, this question here, they want us to use Taylor's method or Newton's method to find the approximate root. So we already been given this root here, which is negative 2,3. Just in case you don't know what that root is, basically that root is an approximation of the value of the interception there on our graph. That's the reason why I left this graph here, so that you can know what exactly is happening here. So that negative 2,3 is an approximation of the point there on the x-intercept. So on this question here, they want us to find two approximation of this root, which are way closer or more accurate compared to the one that is given to us. So as you can see, they say the first and the second approximations, meaning we're gonna only do two approximation and then we are done. Right. So let's start analyzing. So before we analyze though, we have this formula for Newton's method or Taylor's method. And the formula goes like this. We have x n plus 1 is equaling to x nth minus f of x divided by f of x prime. So this formula here is a formula that we're going to use to calculate the approximations that they are asking us to find. So basically what we're doing here, we're trying to find the accurate value of x-intercept by using this formula here. So to explain it further, when you get the same approximation, it means that that is the correct answer, or that is the one that is very, very close to the correct answer there on our x-intercept. Now let's first label here. We have x0. X0 is actually the one that is given to us there, which is -2, 3. So we need to find x1 and x2. So x0 will be part of xnth there. So we need to find f of x and f of x prime there. So first of all, let me write f of x here. Our f of x, as you can see, is the question that is given to us, is x cubed minus 3x plus 5. There we go. And then our f of x prime is the derivative of f of x, which is going to be 3x squared minus 3. There we go. So we're going to use these to calculate the values of f of x in our formula and f of x prime in our formula. So let's start by finding our f of x. Instead of writing f of x, how about we write f of -2, 3, and then we just substitute with -2, 3 wherever there is x there. So let's do it. So let's substitute -2, 3 to the power of 3 minus 3, and then we have -2, 3 plus 5. There we go. So from here, we just use our calculators. If we use our calculator, it's going to be -0,267. There we go. So this is our answer for this one here. For f of x prime, but this time around, it's not going to be f of x. It's going to be f of -2, 3 prime. -2, 3 prime. But it's based on this derivative here. So wherever there is x, we're going to put -2, 3. So we have 3 multiplied by -2, 3 squared minus 3. So what do you get there? I'm getting 12,87. Remember, use your calculators, guys, to make sure that you get the right answer. Now, let me just highlight here. This one here, when you substitute on the formula, it's going to go there on the f of x. And that one there, when you substitute on the formula, it's going to go there on f of x prime. So let's do some substitution. So let's create a little bit of space here so that we can able to get the right answer. Now we find x1. So x1, the formula is going to go like this. It's going to be x1 is equaling to x0 minus f of -2, 3 divided by f prime of -2, 3. So basically, we're just going to substitute the values that we have there. All right, we don't have enough space. Let me erase our graph because we don't need it anymore. We can continue from this. So we know that x1 is equaling to, now instead of writing x0, we're going to take this -2, 3 because that is x0. We're going to write -2, 3 there. There we go. Minus, remember the formula says minus there. And then we have to insert this f of -2, 3. F of -2, 3 is this one here, guys. We just did some calculations. So make sure you put them inside the bracket there. So the answer is -0,267 divided by. Now, if you continue, look at the formula. This is divided by f of -2, 3 prime, which is a derivative there, which is going to be this one there, which is going to be 12,87. There we go. So you put this on your calculator to find x1. As I put this on a calculator, I'm getting the following: -2,279. So this here is our x1, is the first approximation. Now it's time for us to find the second approximation. We do the very similar thing that we did before when we were looking for x1. We need to find our f of x and our f of x prime. So this time around is no longer f of x -2, 3. This time is f of x -2,279. Remember, now we use x1 now. There we go. So this is going to be equaling to, so we're going to look at the original equation. Wherever there is x, we're going to substitute with negative 2,279. Let's do it. Negative 2,279. Let's not forget this is cubed. Minus 3 multiplied by negative 2,279 plus 5. So if you put this on your calculator, what is it that you're going to get there? I'm getting 0,0002. There we go. Right, before we continue, remember inside the bracket there, they said we must have our answers in 3 decimal points. But the problem is after 3 is still 0. So if it's like this, continue until you insert the number there. All right, so let's continue. Let's find our f of x prime in terms of negative 2,279. So let's do it. So f of negative 2,279 prime is going to be as follows. So we're going to substitute that negative 2,279 on the derivative. So it's going to be 3. Wherever there is x, we must substitute negative 2,279. But let's not forget this is squared minus 3. So what I'm getting here is 12,581. There we go. This is the answer for f of x prime, or f of negative 2,279 prime. Right. Again, we're going to apply the formula. So this time around, we are looking for x2. Now let's write the formula. So we're going to have x2 is equaling to x1. Remember, when we're looking for x1, this part here, it was x0. Do not forget that. Minus. Now the formula doesn't change, still the same. We have f of negative 2,279 divided by f of negative 2,279 prime. There we go. So this is the formula. Now it's time for us to do some substitution. Before we do that, let's create some space. All right, so let's do it. So x2 is equaling to x1. Remember, x1 is this one that we calculated earlier, guys. So don't forget that. So it's going to be negative 2,279 minus. Then inside the bracket, we need to put f of negative 2,279, which is this one here, which is going to be 0,0002, divided by f of negative 2,279 prime, which is this one here, which is going to be 12,581. Then close bracket. Then you insert this inside the calculator. Your answer I'm getting here, it's negative 2,279. So it doesn't change as much. As you can see, this here is x2, the same as this one here, x1. Basically, this method that we just use is to get the root or the x-intercept closer to the correct one. Since it doesn't change that much, it means that our answer is actually negative 2,279. This here, guys, is how you do it. I hope this video helped you to understand how to solve this type of a problem. If it so happened that you didn't understand, somewhere you got lost, do not forget to rewatch at the point where you got lost. And again, if that doesn't help, you can leave a comment on the comment section. But this is how we actually do this question here. Again, people, if this video helped you to understand, do not forget to like the video, share the video to your friends, and also if you haven't subscribed to the channel, subscribe to the channel. All right, people, we are done with 3.1.4. Now that we are finished with this one, let's go and do 3.2. All right, guys, here's our 3.2. Now let's read the statement there. As you can see, now the statement goes like this: a particle moves along a horizontal line according to S is equaling to 1 over 3 t cubed minus 2 t squared plus 3t, where S is the displacement in meters at time t in seconds. So guys, we are given this formula here. Now this formula is the formula for displacement, and then S it's for displacement, and t is for time in seconds. So the displacement is in meters and then time is in seconds. Now this part here is what you call rate of change. So basically what you're going to do here, We're going to use this formula to answer the questions that follows. So the first question on 3.2, which is 3.2.1, they want you to calculate the displacement of the particle after 2 seconds. So we already been given the formula for displacement. All you have to do here is substitute. Remember, t, it's 2 seconds. So wherever there is t, we just have to substitute with 2. So the formula goes like this. We have s, right, which is going to be equaling to 1 over 3, open bracket. So wherever there is t, we have to substitute with 2. Remember, this 2 seconds there stands for time. Let's not forget we have cubed there, minus 2. And then again, we have t squared. Instead of writing t squared, we're going to write 2 squared plus 3. And then instead of writing t, we're going to write 2. Right, so whenever they say calculate the displacement and they give you time, all you have to do here, you just substitute the time there. Wherever there is t, you put 2. So you put that on your calculator. And what I'm getting here is actually 2,3 or 0,667 meters. Guys, do not forget, we are calculating the displacement. Always put the SI units. In this case now, for displacement, it is meters. So this here is your final answer. Really, this was not difficult. Just in case, again, you didn't understand, please do not forget to leave a comment. I'll try to answer it to my level best. But if you manage to understand this, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. We are done with 3.2.1. How about we do 3.2.2? All right, 3.2.2. Let's read the question. Here's our 3.2.2. The question says, find the velocity at time t and after 4 seconds. So basically what they want here is for us to find velocity. How do you find the velocity in a formula like this one here? Remember, this formula here, we have to use it through and through. Now, velocity is as follows. So you have to derive this formula, the original formula here, in order for us to find the velocity. So let's derive it. So you can write it as ds over dt, or you can also write it as v of t. Then you derive it. What's the derivative of 1 over 3 t cubed? This is going to give us t squared. If we do the derivative here, this is the standard derivative, guys, minus. And then the second term is going to be 4t, and the third term is just going to be 3. There we go. So this here, you're going to use this formula to calculate the velocity. Now, look, you are given the seconds, which is 4. So this time around, we're going to substitute 4 wherever there is t. So you can say v of 4, wherever there is t, we're just going to put 4 there, 4 seconds. It's going to be 4 squared minus 4 multiplied by 4 plus 3. So if you put this on your calculator, your velocity is going to be 3 meters per second. Do not forget, guys, velocity, it's always in meters per second. So this is your answer here, guys. Remember, when you calculate the velocity of this particle, you need to derive the displacement formula so that it can be the velocity formula. So this is basically how you calculate the velocity. Okay, people, we are done with this question. Just in case you didn't understand, you can rewatch the point where you didn't understand. And if that doesn't help, please leave a comment. I'll try to help you to my level best. But if this video helped you to understand, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. We are done with 3.2.2. How about we continue and do 3.2.3? Let's look at 3.2.3. This is the question there. Now, the question goes like this, guys. At what time is the particle at rest? Now, the question, they want us to find the time at which this particle is at rest, when the particle is not moving. So what you need to know is that when the particle is not moving, there is no velocity. So earlier on, we did derive the displacement formula, and then we said v of t is equaling to t squared minus 4t plus 3, right? But then when this particle is at rest, this means that v of t, which is our velocity, it's 0. So meaning we can say t squared minus 4t plus 3. This is actually the formula for velocity. Is going to be equaling to 0. So when it's like this, we need to find t. So from here, we need to factorize. So how are you going to factorize this? Let's open the brackets there, guys. Let's open the bracket. So we know that the factors of t squared is t and t, but the factors of 3, when you add them, they give you 4. It's 1 and 3. So 1 and 3, when you multiply them, they're going to give you 3. But when you add them, they're going to give you 4. But we need to put negative and negative there. So when we continue, our time is going to be 3 seconds and our time is going to be 1 second. Remember, they said you must find at what times. Remember, times, not time. It's possible for us to have more than one set of times here. So it's 3 seconds and 1 second. So these are your times at which your object was at rest or was not moving at all. So I hope you understand this, guys. Just in case you didn't understand, again, do not forget to rewatch the point when you got lost. And if that doesn't help, comment on the comment section. And again, if this helped you to understand, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. We are done with 3.2.3. Let's do the last question of this question 3, and then we are done with question 3. All right, here's our last question. Now, last question is 3.2.4, which is this one here. It goes like this. Find the acceleration at time t and after 4 seconds. So acceleration, how do we calculate acceleration? Now, let's start from the beginning. Remember, we have the displacement. It goes like this. We have 1 over 3 t cubed minus 2t squared plus 3t. This is the formula for displacement. When we derive this, which is going to be ds over dt, or which is the same as v of t, which is the velocity, we're going to have t squared minus 4t plus 3. So this is the first derivative, which is equaling to the formula for velocity. In order for us to find the formula for acceleration, we need to do the second derivative. So you can do it this way, second derivative, right? So it's d squared s divided by dt squared. All this is equaling to a of t. A, which is acceleration, by the way. It's going to give us the second derivative of our formula, which is going to be 2t minus 4. So this here is our formula for acceleration. Guys, whenever they say calculate acceleration and they give you the time there, you need to do the second derivative. Right, so all you have to do here now is to substitute our time, which is 4 seconds from the statement, on our formula. As you can see, we have 2t minus 4. So wherever there is t, we put 4 there. So it's going to be 2 multiplied by 4. Remember, our seconds from the statement is 4 minus 4. So if you continue, a of t, which is acceleration, is going to be 8 minus 4. And then this is going to give us 4 meters per second square. Guys, do not forget this is acceleration, so this s is gonna be squared, so it's meters per second square. Guys, do not forget to write the SI units on this type of questions. If you can pay attention to this question and you've done science, you notice that it's the same as science. It's just that we are using differentiation to calculate velocity and acceleration by deriving the formula of the displacement. I hope you guys managed to understand this part of the question. Really, it was not that difficult. What it needed you to do is to understand what is the first derivative equivalent to, the second derivative, what is the equivalent to, and when the object is at rest, what is the meaning of that? What is the value of the velocity when the object is at rest? But other than that, this was very, very straightforward. I hope you guys managed to understand this. Just in case you didn't understand, go to the point where you didn't understand, rewatch the video. And if that doesn't help, you can always comment on the comment section, guys. I'll try to help you to my level best. But if this part of the video helped you to understand how to solve this type of a problem, do not forget. All right, guys, here is our question 4. Now, question 4, it is based on integration. If you can look at 4.1 there, they say determine the sigma y dx in each of the following cases. And it also has 4.1 and 4.2. All these questions that you see here are integral questions. So let's look at 4.1.1 and let's solve it. All right, here's our 4.1.1. Now, like I said earlier, that this question is supposed to integrate. So 4.1.1, we have y is equaling to, on the numerator, we have x open bracket 2 minus 3x close bracket divide by, on the denominator we have e to the power of 3x plus x squared. Now they also gave us a hint there. So the hint goes like this: let u equaling to 1 plus x squared multiplied by e to the power of negative 3x. So we need to use the substitution. So let me rewrite this question so that we can solve it. So when you rewrite this, rather include the sigma for now. Let's simplify the numerator there. Let's remove the brackets. If we multiply x with the 2 there, we're going to have 2x on the numerator. And x multiplied by negative 3x, we're going to have negative 3x squared. All this is divided by the denominator. You also need to simplify this denominator there. So we need to take out the common factor, which is e to the power of 3x. So this is where the trick was. If you take out e to the power of 3x, the first term there is going to be 1 plus the second term there is going to be x squared. But it never had e to the power of 3x, meaning you need to introduce e to the power of negative 3x close bracket. This means that if you multiply by this e here outside the bracket, it's supposed to take you back to that expression there on the denominator. Right, I hope you guys can see that. So this here, we can write it as multiply by dx. There we go. Now that we are given a hint that u must be equaling to 1 plus x squared e to the power of negative 3x, we need to derive this one here. So if we derive this, we know that du over dx. Now the first term we have 1, it's a constant that is going to give us 0. We cannot do that one, we leave it. But the second term here, as you can see, this is a product rule. Just in case you don't know much about product rule, there is a video on product rule. I'm going to leave that video on the description. Go and click on that description, and also the very same video will pop up on the top right of the video that you're watching. Go and watch that video to understand the product rule. So the product rule goes like this. You derive the first one here, which is going to be our x squared. Let's derive it. It's going to give us 2x multiplied by. Now you leave the other function, which is going to be e to the power of negative 3x. Right. Always you plus them. Now you leave the first one, which was x squared, but this time around you derive e to the power of negative 3. So when you derive e to the power of negative 3x, this is going to be negative 3 multiplied by e to the power of negative 3x ln e, close bracket. So as you can see, this needs to be simplified further. So let's simplify it further. So if you continue here, we can say du over dx is equaling to 2x multiplied by e to the power of negative 3x minus, because if you multiply with this negative here throughout, everything's going to be minus them. So we're going to be left with 3x squared multiplied by e to the power of negative 3x, because ln e is equaling to 1. Right, so this is what we have at the moment. So let's continue. Let me zoom down because we actually need this space here. So I hope you guys can see. All right, so when it's like this, we can write this like following. We have du over dx. We can say 2x. And then since we have e to the power of negative 3x, we can rewrite this as e to the power of 3x on the denominator minus. Same here, we have 3x squared divided by e to the power of 3x. This here, guys, is exponential law, just in case you don't know much about it. Let me continue here at the top. We have du over dx, right? Now, if you can look at our denominator, is the same there. We have e to the power of 3x for both the terms here. So we can see all this is divided by e to the power of 3x. And what we have on the numerator, we have 2x minus 3x squared. There we go. So if you pay attention to this whole thing here, you will see that on our formula, we actually do have that derivative there. There we have 2x minus 3x squared divided by e to the power of 3, which is that. But this time around, it is multiplied by 1 plus x squared multiplied by e to the power of negative 3x. So how are we going to substitute that? First of all, let's make du subject of the formula. So du is the subject of the formula, meaning we need to cross multiply this. We can say 2x minus 3x squared divided by e to the power of 3x multiplied by dx. There we go. So whenever we see 2x minus 3x squared divided by e to the power of 3x multiplied by dx, we must substitute it with du. So let's go back to this one. Now, if we set sigma, let me rewrite it in a way that can be easy for us to substitute. Open bracket, 1 over 1 plus x squared e to the power of 3x. Close bracket. Multiply. Remember, we were left with what here? 2x minus 3x squared divided by e to the power of 3x multiplied by dx. So this part here, let me highlight very quickly. This part here is the same as that part there. Let me highlight very, very quickly, guys. I hope you can see. There we go. It's the same. It's just that I separated them. But for the fact that we have multiplication, they can take you back to that question. Now, let's do some substitution. Let's start with the one inside the bracket there. This is sigma. We have 1. There we go. Divide by this here we said is equaling to u. If you still remember them, that is equaling to u. So we're going to substitute that with u. There we go. Multiply by all of this, which is that there, is equaling to du. So we can write that as du. There we go. Then we start integrating. Right. So from here, this is integral of ln. When we have something like this, we know that this is going to give us y is equaling to ln u plus c. But we know that u it's actually 1 plus x squared multiplied by e to the power of negative 3x. So we're going to say ln, instead of writing u, we're going to write this 1 plus x squared e to the power of negative 3x, close bracket, plus c. So this here is our final answer. Right. Obviously, there are other ways of doing this, but since they gave us a hint to use 1 plus x squared multiplied by e to the power of negative 3x, substitution was the way to do this. Right, people? I hope this was not difficult. It seems so difficult, but if you knew your substitution, then it was going to be okay. So if you managed to understand this, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. But if it so happens that this doesn't make sense, you go to the point where you got lost, rewatch it, and if that doesn't help, ask on the comment section, and I'll try to answer you to my level best. Right, people, we are done with question 4.1.1. Let's go and do question 4.1.2. So people, here is our 4.1.2. So this question here, they want us to integrate this question here. So it goes like this. Y is equaling to cos to the power of 7x multiplied by sine to the power of 3x. So we need to rewrite this. So let's do it. We have to include the sigma there. And then let's put this inside the bracket. Obviously, we have cos to the power of 7x multiplied by sine to the power of 3x multiplied by dx. Right. So on this type of a problem, we need to change one of these trigonometric ratios so that they can be the same when we integrate. So let's rather change cos to the power of 7. Remember, we are simplifying, we are not integrating yet. You can say cos to the power of 6x multiplied by cos x, right? Multiplied by sine to the power of 3x, close bracket, dx. The aim here is to make sure that at least we have cos to the power of 1 there. Then when it's like this, we can change this cos to the power of 6 in terms of sine. But before we do that, let's first do the following. We can say sigma, open bracket. We can say open bracket again, cos to the power of 2x. Then outside there, we can say to the power of 3. If you multiply this exponent of 2 with that exponent of 3, they're going to give you the exponent of 6. So I hope you know this. These are exponents law. Again, just in case you don't know much about exponents law, I've made a video explaining the exponents law. So I will leave that video in the description. Go and watch that video just in case you want to understand the exponent laws. That video also will pop up on the top right of the video that you're watching. Click on the icon there and watch the video. Right, let's continue. So let me just write it like this for now. Sine to the power of 3x multiplied by cos x, and then close bracket, and then dx here. Remember, I said earlier, we need to change cos in terms of sine. So how are we going to do that? We need to use the square identity. So if we use the square identity, if you still remember, we have cos squared x plus sine squared x is equal to 1. So we can make cos squared x subject to the formula, which is equal to 1. And then transpose this sine squared to the right-hand side, we're going to have negative sine squared x. There we go. So instead of writing cos squared, we can write 1 minus sine squared x. So let's do it. Sigma, open bracket. So we're going to open this one here. Instead of writing cos squared x, we're going to write 1 minus sine squared x, close bracket, to the power of 3, multiplied by sine cubed x, multiplied by cos x, close bracket, dx. There we go. So we're still simplifying, guys. We haven't yet integrated. Right. In order for us to integrate this, we need to factorize this here because it has the power of 3. So the shortest method I can think of is the following. We can say 1 minus sine squared x squared multiplied by, open bracket, 1 minus sine squared multiplied by sine cubed x multiplied by cos x dx. There we go. Let's close the bracket like that. I hope you guys can see this. Let me create a little bit of space here so that you can see. So if you pay attention, this part here and that part there, when they multiply each other, they're going to give you this. So let's continue here at the top so that we can able to solve this further. So if you continue here, obviously we're going to write sigma there. So first of all, we have to factorize this one here inside them. So how are we going to factorize this? It's very simple. There is a shorter method that we can use to factorize. First of all, the method goes like this. You can say 1 multiplied by 1. It's going to give us 1 there. And then you say 1 multiplied by negative sine squared x multiplied by 2. This here is going to give us negative 2 sine squared x. And then we do the last one. We have negative sine squared x multiplied by negative sine squared x. This one's going to give us positive sine to the power of 4x, close bracket. But let's not forget, we still have 1 minus sine squared x again to the power of 1. Open bracket, 1 minus sine squared x. There we go. We still have sine to the power of 3 and also that cos x there. So let's write them. We have sine to the power of 3x multiplied by cos x multiplied by dx. So this here, you can put it inside the bracket like that. There we go. We also need to get rid of these brackets inside them. So let's continue. So sigma, open bracket. Now we have to multiply what is inside the bracket. So we're going to start by multiplying 1 with that one. Then we're going to get 1. We multiply 1 with negative 2 sine squared x. We're going to get negative 2 sine squared x. We multiply 1 with positive sine to the power of 4. So we're going to get plus sine to the power of 4x. Now we do the multiplication of negative sine squared x. So if you multiply this negative sine squared x with 1, it's going to give us negative sine squared x. There we go. If you multiply the very same negative sine x with negative 2 sine squared x, this here is going to give us positive 2 sine to the power of 4x. There we go. And then if you multiply the very same negative sine squared x with positive sine to the power of 4, this is going to give us negative sine to the power of 6x, close bracket. Let us not forget we still have sine to the power of 3 and also cos x there. So let's write them. Sine to the power of 3x multiplied by, let me zoom down so that we can able to finish this. We have cos x close bracket multiplied by dx. So from here we have like terms. So let's highlight the like terms here. We have negative 2 sine squared x and another negative sine squared x. Those are the like terms. And we also have positive sine to the power of 4 and positive 2 sine to the power of 4. Those are also like terms. If you continue, let me continue here. Sigma, open bracket, do this bracket like this. We have 1, so we're going to write 1 there. And we have negative 2 sine squared x and another negative sine squared x. They're going to give us negative 3 sine squared x. There we go. And then we have the following: positive sine to the power of 4x with another positive 2 sine to the power of 4x. So this is going to give us plus 3 sine to the power of 4x. There we go. And the last one, we are left with negative sine to the power of 6x. And we close bracket. Don't forget, outside there, we are also having sine to the power of 3x. There we go. Multiplied by cos x, close bracket, dx there. So we need to get rid of the brackets, meaning we have to multiply this sine to the power of 3x with everything that is inside them. Please do not multiply by cos yet. Sigma. If we multiply this sine to the power of 3, if you multiply it with 1 there, we're going to have sine to the power of 3x. And then we multiply it with negative 3 to the power of sine squared. This is going to give us negative 3 sine to the power of 5x. There we go. And then we multiply this sine to the power of 3x with 3 to the power of sine 4x. This here is going to give us plus 3 sine to the power of 7x minus. And then we multiply this sine to the power of 3x with negative sine to the power of 6x. That is going to give us negative sine to the power of 9x. There we go. Close bracket. So we left with what here? Cos x, close bracket, dx. There we go. So this here, guys, we can for now leave it like this, and then let's use substitution to solve this. So we can say let u equaling to sine x. Let's derive. If we find du over dx, what is the derivative of sine? It's going to be positive cos x. We all know that. So wherever there is sine, we substitute with u. But we are not done with this one here. We need to make du subject to the formula. If we make du subject to the formula, du is going to be equaling to cos x multiplied by dx. There we go. Now, before we continue, look at du. Du is equaling to cos x multiplied by dx. We actually have this here on our equation, meaning this part here, we can substitute it with du. So hopefully you guys can see that. Let me create a space so that we can able to continue. All right, let's continue. So we have sigma. There we go. So wherever there is sine, remember we substitute with u. So we have sine to the power of 3. This is going to be u to the power of 3 minus 3 sine to the power of 5x. This is going to be 3 u to the power of 5. And then plus 3 sine to the power of 7x. This is going to be 3 u to the power of 7 minus sine to the power of 9. This is going to be u to the power of 9, close bracket. Instead of writing cos x dx, we're going to substitute with du. So multiply by du, like that. So when it's like this, it's easy for us to integrate. So let's integrate this. By the way, this is a standard integral. We are all good. So when we integrate, remember, we're going to equate this to y, and then we use the standard integral. So with the standard integral, it goes like this. You have u to the power of 3 plus 1 divided by 3 plus 1. There we go. Minus. We have 3, and then we have u to the power of 5 plus 1 divided by 5 plus 1. The plus, we have 3 u to the power of 7 plus 1 divided by 7 plus 1. And the last one, we have negative u to the power of 9 plus 1. It's going to divide it by 9 plus 1 plus c. Let us not forget c to show that these are indefinite integral. So if you continue here, we're going to have u to the power of 4 divided by 4. And then minus, we're going to have 3 over, what is 5 plus 1? This is going to give us 6. And then we have u to the power of 6. There we go. Plus, we have 3 divided by, we have 7 plus 1. That is going to give us 8. And we have u to the power of 8 there. Then we have minus, we have u to the power of 10 divided by 10 plus c. Let us not forget that u is the same as sine x. Let's substitute it back. Let me create a space a bit. Let's substitute it back. So y is equaling to, wherever there is u, we have to substitute by sine. Sine to the power of 4x divided by 4. There we go. And then minus, we have 3 divided by 6. This is going to give us 1 over 2. And then u to the power of 6, that is sine to the power of 6x. There we go. Plus 3 divided by 8. And then we have u to the power of 8. That is going to be sine to the power of 8 and x. And then the last one here, we have u to the power of 10. That is going to be sine to the power of 10 x divided by 10 plus c. Here is our final answer, guys. This here was long, so I hope you guys managed to understand it. Obviously, if you understood what was happening, it was not going to take you this long. Well, guys, here is 4.1.3. Now, 4.1.3, they want us to integrate the following here. Y is equaling to cos pi over 2x sine pi over 4x. Now, this here, guys, it's an identity. As you can see here, we have this identity on our right-hand side. So this identity starts with cos A sine B. So we can say here on our problem, this here is A pi over 2x, and then this here it's B pi over 4 multiplied by x. There we go. So we can able to use this identity here. So let's substitute. Remember, we need to introduce sigma there. So if you look at this here, it's supposed to be substituted. We have half, right? And then open bracket. We have sine A plus B, but our A here is actually pi over 2x plus B, which is pi over 4x. There we go. Then we say minus. There is minus there. So we say minus there. And then we write sine. We have A minus B. There we go. So our A is pi over 2x minus B, which is pi over 4x. Close bracket. And all this here is multiplied by dx. There we go. So from here, guys, we just have to add these angles and subtract them. So we can take out the half outside the sigma. Let's take it out. And then we left with open bracket sine. So what do we have inside the bracket there? What is pi over 2x plus pi over 4x? So what I'm getting here is 3 over 4 pi x. There we go. Then I close the bracket there. Minus sine. So this one here, we have pi over 2x minus pi over 4x. So what do we have there? When I have 1 over 4 pi x. There we go. And this here multiplied by dx. So when it's like this, we are finished with the simplification. It's time for us to integrate. So let's not forget that this we can equate it to y and say 1 over 2. And then we put the integral there. Now, remember, when you integrate the trigonometric ratio, you divide by the coefficient there. So let's do it. So first of all, we know that the integral of sine is going to be negative cos. There we go. So we must include this here, 3 over 4 pi x. There we go. But then we need to divide by the coefficient of x there, which is 3 over 4 pi minus. Now, what is the integral of sine? Remember, the integral of sine is negative cos. We have to write the angles there. We have pi over 4x. There we go. Close bracket. And then we have to divide by the coefficient there, which is going to be pi over 4. Then close bracket plus c. There we go. So from here, we can say y is equaling to 1 over 2, open bracket. What we have here, we have a fraction, which is 3 over 4 pi, dividing this cos there. So when you have a fraction dividing them, this denominator must multiply there on the numerator, and you leave this 3 pi there. So when you write this, this is going to be negative 4 cos, then open bracket, 3 over 4 pi. There we go. Divide by, all this is divided by 3 pi. Then we have minus and minus. This is going to give us positive. Again, we have a fraction, which is pi over 4 dividing there. This 4 here is going to go on top there. Right, so this is going to be 4 cos, then open bracket, pi over 4x, and then all this is divided by pi. Because the pi there, it's remaining on top there. We close the bracket and we say plus c. Right, let me create a space so that you can be able to see. As you can see, we still have the half there. You need to get rid of the bracket by multiplying with this half throughout. So if I say 1 multiplied by the numerator, let's start with this one here. It's going to be 4 cos, open bracket, pi over 4x, close bracket. But then on the denominator, we have this 2 here. 2 multiplied by pi is going to be 2 pi. There we go. Then we continue. Minus, because this one here, it's minus. Then we multiply by 1 on the numerator. We have 1 multiplied by negative 4. This is going to be the negative 4 cos 3 over 4 pi x. And then divide by, we have 2 multiplied by 3 pi. This is going to give us 6 pi plus c. Do not multiply the c with the half. The half only affects the integral, not the constant. Now, let's continue. Simplify it further. If we simplify it further, we have 4 divided by 2. This is going to give us 2 cos, open bracket, pi over 4x. And then we are divided with pi, because this here is going to be gone. Minus. And then we have 4 over 6. 4 over 6 is the same as 2 over 3. And then we still have pi there. Then we can say cos, open bracket, 3 over 4 pi x, close bracket. So this here, guys, is our final answer. Let us not forget plus c. So this is our final answer, guys. Just in case you did not understand, you can leave a comment in the comment section, and you can always rewatch at the point where you got lost. Right, people? But if this helped you to understand how to integrate this type of a question, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. We are done with this question here, which was 4.1.3. Let's go and do 4.1.4. All right, guys, here is our 4.1.4. Now, as you can see, we have a fraction here. This here is an integration of algebraic fractions. So we're going to integrate this one here, guys. Unfortunately, this one is going to need us to use the long division method. So before we do that, how about we rewrite it here on the screen? We're going to put sigma there, and we have 2x to the power of 3 minus 5x squared plus 6x plus 12. All this is divided by x minus 4. Let us not forget it is multiplied by dx. From here, guys, we have to use the long division method. So on this side, you're going to write the divider. And then inside here, we're going to write the numerator. 2x cubed minus 5x squared plus 6x plus 12. Right, so the long division goes like this, guys. First, you divide this 2x cubed with x. You're going to be left with 2x squared there. So the next step is you multiply this x minus 4 with 2x squared. So if you say x multiplied by 2x squared, that is going to give us 2x cubed. And then you multiply this negative 4 with 2x squared, that is going to give us negative 8x squared. And the following step there is you subtract or add these. So these ones here inside the bracket, they will change the sign. You just multiply by negative. Now this 2x cubed becomes negative minus that 2x cubed. This is going to give us 0. This here becomes positive. If it becomes positive, just know that we have negative 5x squared plus 8x squared. That is going to give us plus 3x squared. Right, after here, we're going to drop this 6x. We're going to have positive 6x here. And then we drop this 12 here. We're going to have plus 12. Then from here, we repeat the same step again. We're going to divide this 3x squared with that x there. And then the answer is going to be plus 3x. Then the next step here, we're going to multiply this 3x with x minus 4. So what is x multiplied by 3x? This here is going to give us 3x squared. There we go. And then what is 3x multiplied by negative 4? That is going to give us negative 12x. Then we put this inside the bracket. We multiply by negative to change the signs. Right. So if we change the sign here, this negative 3x squared and that positive 3x squared, they're going to give you 0. So if you multiply by this negative 12x is going to become positive 12x plus 6x. That is going to give us plus 18x. Then we drop this 12. There we go. So we have the following now. So the next step here, we're going to divide this 18x with x there. And then we're going to have plus 18. So the next step here, you have to multiply this 18 with x minus 4. There we go. If you multiply this 18 with x minus 4, this is going to give us 18x. And then negative 4 multiplied by 18, that's going to give us negative 72. There we go. Now you have to put this inside the bracket and multiply by negative 1 so that you can change the sign. So let's zoom down so that you can be able to solve this further. All right, so from here, we have to subtract and add this. So if you multiply by this negative outside the bracket, this 18x is going to be negative. Negative 18x plus 18x, that's going to give us 0. If you multiply this negative with negative 72, that's going to give us positive 72. And then if you say 72 plus 12, that's going to give us plus 84. So this is here is our remainder. So let's continue here. We can say the sigma of 2x squared plus 3x plus 18 plus 84 divided by x minus 4 and then close bracket dx. Right, just in case you don't know where these are coming from, this here 2x squared plus 3x plus 18 is what we got there as we are dividing them. And then this 84 there, it is the one there. And then divide by x minus 4, which is our divider there. So 84 is actually our remainder, just in case you did not know. So let's start integrating this. So before we do that, I think it's best for us to separate this. I can do it this way. I can say sigma 2x squared plus 3x plus 18 dx plus sigma 84 over x minus 4 dx. Right, so the fractions decided to do it separately. Now let's just drop it for now. We can say sigma 2x squared plus 3x plus 18 dx. Now we can take out this 84. Let's say 84 then sigma, and then we have 1 over x minus 4 dx. Then from here, we can start integrating. So the integral of the first one here is going to be 2x 2 plus 1 divided by 2 plus 1. There we go. Plus we have 3x, 1 plus 1 is exponent divided by 1 plus 1. And then we have plus 18x. Guys, when it's constant and we are integrating, we just multiply by the variable we are integrating with respect to. Plus, so let's look at the fraction there. We all know that we have 84 here, but this one here, the one of ln. So we can integrate this by saying ln x minus 4, and then the final, it's plus c. So let's simplify it further. Let me create a space here, guys. You can say y is equaling to 2x, exponent with 2 plus 1, that's going to give us 3 divided by 3 plus. And then here we have 3, we have the power of 1 plus 1, that is going to be squared divided by 2 plus 18x plus 84 ln, open bracket, x minus 4, and close bracket, that is going to be plus c. So here, guys, is our final answer. I know this can be challenging for most people because of the long division method, but all in all, this was straightforward for those who managed to do the long division method. Just in case this video helped you to understand this part of integration, do not forget to like, share, comment, and subscribe to the channel. But if you didn't understand somewhere, you can go to the point where you got lost, rewatch the video. If that doesn't help people, leave a comment on the comment section, and I'll try to help you to my level best. All right, people, we are done with question 4.1.4. Let's go and do question 4.1.5. All right, let's look at question 4.1.5. Now we have the following expression. It goes like this: y is equaling to 4x multiplied by cos 4x. Now this one here, guys, it's actually integration by parts, just in case you didn't notice. So with integration by parts, you need to know your priority list. Let me just write it here on the side. So this priority list, it goes like this. Whatever that comes first is supposed to be f of x. So number 1 here, it's supposed to be ln x, and then 2, it's gonna be x to the power of nth, and then we have 3 there. This one is when you have exponential function. Guys, here's our priority list. It goes like this. The one on top always takes f of x. So I will explain it later as we continue. So the formula goes like this. For by parts, you will have sigma, right? And then you have f of x multiplied g of x prime dx. So what you should know here, guys, is that we're gonna have 4x multiplied by cos 4x dx. Guys, one of these must be f of x and the other one must be g of x prime. As you can see from the priority list, this one here, which is 4x, is the same as the second one on the priority list. So it means that it's gonna be the f of x because of the trigonometric ratio. It's underneath there. So if we have to name these ones here, we can say 4x is our f of x, and then cos 4x is going to be g of x prime. So when we integrate this, it's going to go like this. Y is going to be f of x multiplied by g of x minus sigma. And then this time around, we derive f of x, and then we have g of x. There we go, dx. Right, so from here, let's use this formula to get our answer. Now, the formula goes like this. It says, the first step, you write f of x there. Our f of x is going to be 4x. There we go. And then we integrate g of x. Remember, g of x is prime from the equation. So the integral of cos, first of all, is going to be positive sine. And then we have 4 there. But when we integrate, guys, the trigonometric ratio, we always divide by the coefficient of x, which is 4, minus, right, sigma. Now, what do we have there? We have to derive f of x. So let's derive our f of x there. Our f of x is going to give us 4 when we derive it, multiplied by g of x. Our g of x is sine 4x divided by 4. So it's going to be sine 4x divided by 4 dx. There we go. So we have 4 divided by 4. This here, if you continue, is going to give us x multiplied by sine 4x. There we go. Minus. We have this 4 and that 4, they will divide each other. So we're only left with sigma sine 4x dx. So let's continue. If we continue, let me create a space here. We have to integrate the last part there. When we continue, we're going to left with y is equaling to x multiplied by sine 4x minus the integral of sine 4x. So again, the integral of sine 4x is going to be negative cos 4x divided by 4, close bracket, plus c this time. So our final answer here is going to be x multiplied by sine 4x, negative and negative. This is going to become positive. And then we have cos 4x divided by 4 plus c. So here is our final answer, guys. I hope you managed to understand this one. As you can see, this is a by parts integral. So it required you guys to know the priority list. If you didn't know the priority list, then this was going to be challenging for you guys. And also the formula for by parts. But anyway, if this video helped you to understand how to integrate such problems, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. If you didn't understand, leave a comment at the point where you didn't understand. All right, people, we are done with 4.1.6. Let's go and do the last question. All right, guys, here's our 4.2. Again, 4.2, they are given as a statement there. They say determine sigma y dx by resolving the integral into partial fractions. So this here is actually partial fractions. Now, as you can see, there's a formula for partial fraction. Here they are. We have 1 and 2 there. But we're going to use this one for the question that we have there. Right, people. So be very, very careful. Do not confuse partial fractions with algebraic fractions. Right. So what must we do here? First of all, we need to factorize the denominator there. So let's do it. We can say x minus 5 divided by, we need to find the factors of x squared. I know it's x and x. There we go. And then the factors of 4, when we add them, they give us 5. It's going to be 1 and 4. When you multiply 4 and 1, you're going to get 4. But when you add them, you're going to get 5 there. Because everything is positive inside the bracket, everything must be positive. But all this is going to be equaling to, remember, we're going to use this formula here from the formula sheet. I hope you guys have seen that. So we can say A is equaling to, we're going to divide by one of the brackets there. It's going to be x plus 4. Then we say plus b is going to be equaling to, we divide by the other bracket, which is x plus 1, close bracket. What we need to do here, we need to make this expression here to be linear. So in order for this expression to be linear, we need to multiply by x plus 4 and x plus 1, both sides. So let me just create some space here so that we can be able to solve this. Right, so on the left hand side, we can multiply by x plus 4 and x plus 1. Let's not forget, we also have x minus 5. All this is going to be divided by x plus 4 and x plus 1. There we go. All this is going to be equaling to, open bracket, a divided by x plus 4 plus b divided by x plus 1. Close bracket. Remember, we also need to multiply by the same x plus 4 and x plus 1. There we go. All these are divided by 1. So here we're trying to make this question to be linear. So this x plus 4 and that x plus 4 will divide each other. X plus 1 and x plus 1, they're going to divide each other. So on the right hand side, we're going to be left with x minus 5 equaling to. Now this one here, we have to multiply each term with the outer part. If you multiply a over x plus 4, this x plus 4 and that x plus 4 will divide each other. So you're going to be left with only a and this x plus 1. So x plus 1. There we go. Plus that plus there. And then we do the same thing. If you multiply b divided by x plus 1 with everything that is outside there, this x plus 1 and that x plus 1, they're going to divide each other. So you're only left with b with x plus 4. So x plus 4. Now it's linear. We can start working on it. So the next step here is to use the grouping method. So let's create a space so that we can able to do the grouping method. So the grouping method is very, very simple. You look at the x with the highest power here, especially on the left hand side. We know that x has the power of 1, which is the highest. So we say all the coefficients that are multiplying x to the power of 1, we're going to write them here. So on the left hand side, x to the power of 1 is multiplied by 1 because there's nothing there. So we're going to write 1 there. If there is any term that is multiplying x to the power of 1, we're also going to include it. So on the left, we only have 1 there. So we're going to say equaling 2. Because this negative 5 is not multiplied by x. It's a constant. Right. Then we come to a. A multiplied by x becomes a coefficient. So we can write a there. There we go. Plus. And then we have b multiplied by x becomes a coefficient and it becomes b there. Then this one here becomes our equation. Let's make a subject of the formula. If we make a subject of the formula, we can transpose b to the left hand side. We're going to have 1 minus b is equaling to a. This here become equation 1. Right. Now we group the ones with x to the power of 0 or constant, guys. C. Right. So when you group like that, on the left hand side, we look for the coefficient or the constant. So when you look at the constant here, we have negative 5. So negative 5 is our constant because it's not multiplying by anything but just a number, right? And then this is going to be equaling 2. On the right hand side, we know that a multiplied by 1, this is going to give us 1. So it becomes a constant. So it's going to be a. And then if you multiply here, b multiplied by 4, this here is going to give us plus 4b. There we go. And this here become equation 2. So here, guys, it's another method that we use, which is grouping to find our a and b. So we can say substitute 1 into 2. There we go. So we're going to substitute equation 1 into equation 2. As you can see, equation 2 is negative 5 is equaling to a plus 4b. So wherever there is a, we're going to substitute with 1 minus b. Let's do it. So we can say negative 5 is equaling to, instead of writing a, we can write 1 minus b plus 4b. There we go. And then from here, we can say negative b plus 4b. This is going to give us 3b. And then we transpose this one on the other side. So if we transpose this one, this is going to be negative 5 minus 1. And then we left with negative b plus 4b. This is going to give us 3b. There we go. Negative 5b minus 1, that's going to be negative 6. And then is equaling to 3b. Right, let's create more space. Again, people, more space. So we divide by 3 throughout. So negative 2 is equaling to b. There we go. So if b is equaling to negative 2, we can find a. How? Let's go back to equation 1. Equation 1 is 1 minus b is equaling to a. We can say substitute b into 1. So here's our equation 1. Then we have 1 minus, instead of writing b, we're going to write minus 2 because b is equaling to minus 2. All this is equaling to a. So we can say the 1 minus minus 2, that is going to give us positive 3. So a is equaling to 3. Now that we have a and b, we can able to go back to our equation and substitute them. So let me just zoom down for a minute there. We're going to substitute these values here. So we're going to continue here with the red pen. So we can say sigma. Instead of writing a there, we're going to write 3 over x plus 4. There we go. And then we go to the next one there, which is b. Remember, our b from our problem when we were solving, it was minus. So this is going to be minus 2 over x plus 1. Then this is going to be dx. So we need to simplify this further so that you can able to integrate it. So let me create a bit of space here. we can do the following. We can take out 3, and then sigma, we have 1 over x plus 4 dx, right? Minus. And then we take out 2 there. We're going to have sigma, and then we have 1 over x plus 1 dx. There we go. And then from there, we integrate. Y is going to be equaling to, we're going to write 3 there, and this is going to be ln x plus 4 minus 2 there. It's going to be ln x plus 1, close bracket, plus c. So this here, it's how you do this one. This was actually type 2 of our integration, just in case you didn't know about it. By the way, guys, if this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed, because we are done with question 4 of this question paper. Alright, guys, here is our question 5. Now let's look at question 5. It contains 5.1, 5.2, which has sub-questions from 5.2.1 to 5.2.4. And then the last question of question 5, it's 5.3. So we'll start with question 5.1. So let's create a space here and let's solve 5.1. Alright, guys, here is our 5.1. It goes like this: determined by integration, sigma with the upper limit of infinity and the lower limit of 0. It has this e to the power of negative st multiplied by f of t dt if f of t is equal to 7 over 3t to the power of negative 1. Right, there's something that we need to do here first before we do anything else. We know that our f of t is given to us as this one here. We can rewrite it like this: 7, instead of writing t to the power of negative 1 on the denominator, we can write t on the numerator. If we take the base, which is t there, to the numerator, the sign of the exponent will change and become positive. And then on the denominator, we're left with only 3. Right, now let's rewrite this in this term. Right, so we have sigma, right, the upper limit, which is infinity, the lower limit, which is 0, and we have e to the power of negative st multiplied by f of t. Now f of t, we can write it as 7t divided by 3 multiplied by dt. So here we are actually integrating with respect to t. If you look at this integral here, you can see that this is actually integration by parts. So how can you do this? First of all, let me just write the formula for integration by parts. So I'm going to do it this side here. So you'll be given something like this: sigma, and then you have f of t. In this case, we're going to use t and multiply by g of t prime dt. Now, usually when you are given an integration by parts, you will have to choose which one is going to be f of t, which one is going to be g of t prime. But on this question here specifically, they already told us, or they already gave us, that f of t is this one here. So automatically e to the power of negative st will become our g of t prime. Now when you integrate, the general formula goes like this: you're going to have your f of t, right, multiplied by the integral of g of t prime, which in turn is going to become g of t, and then minus sigma. Now this time around, you differentiate f of t. There we go. And then you multiply it with g of t, and then we have dt there. So this is the formula that you must use. So it's really not that difficult, guys. The best thing that you can do there, let's first name them. We have f of t, right, which is actually 7t over 3. When you differentiate this, this is going to be f of t prime, right, which is going to be 7 over 3. There we go. And then we have g of t prime, which is e to the power of negative st. And then when we integrate this, this is going to be g of t, right? And then the integral of g of t is going to be negative e to the power of negative st divided by s. There's no need for you to add c here after integration, because this is actually definite integrals. So with this, we can able to substitute them there on our formula for integration by parts, right? So let's continue. I'm going to continue here underneath. Let me create a little bit of space before we continue. All right, let's look at our formula there. It says y is equaling to f of t. F of t, remember, is this one here. So you're going to write it as 7t over 3. And then the next one, you multiply by g of t, which is the integral of g of t prime, which is this one there. So let's do it. Multiply by negative e to the power of negative st divided by s, right? And then if you look at the formula, we have minus there. So we're going to minus. And then we have sigma. Now, after the sigma, what do we have there? We have f of t prime. Our f of t prime is this one there. Let's write it. It's 7 over 3. There we go. Multiply by g of t on our formula. So g of t, it is this one as well. So let's write it. It's going to be multiplied by negative e to the power of negative st over s. Let's not forget dt, because here we are still integrating. So you can do this to show that you are still having the limit. The upper limit is infinity and the lower limit is 0. So let's create space, guys, so that we can be able to solve this problem. Here's our space. So let's continue. The first term there, which is this one here, you have to multiply the numerators. If you multiply 7t with negative e to the power of negative st, we'll be having negative 7t e to the power of negative st. And then on the numerator, we have 3 multiplied by s. This is going to be 3s. And then negative. Rather put this inside the bracket, guys. And then outside the sigma, you can take out the coefficient. If you can look at the whole of what we have inside the sigma, then we're going to take everything that does not have t there. So in our case, we have 7 on the numerator. And then on the denominator, we have 3 and also the s there. So inside the sigma, we are left with negative e to the power of negative st dt. All right, so we are not done integrating. So we have to write our limits here, guys. Infinity and 0. Right, so let's continue. The first term, we can just rewrite it as it is for now. We have negative 7 multiplied by t e to the power of negative st divided by 3s there. Now minus, again, put this inside the bracket. If we can look at what we have here, we have 7 over 3s, right? Oh, by the way, I should have put this inside the bracket. We need to integrate negative e to the power of st. Let's put it inside the bracket. So we have negative e to the power of negative st divided by negative s there. And then we can say this here, guys, is our limit, infinity, and the lower limit there. Right. Let's simplify, guys. All right. So this question here, it needs you guys to simplify. Let's continue. Y is going to be equaling to the first term. Again, leave it as it is. Negative 7 t e to the power of negative st divided by 3s. And then we need to simplify the second term. Look, we have this negative and that negative. They're going to give us a positive answer. But let's not forget, we have to multiply by this negative as well. So if we continue, this here is going to be minus 7 on the numerator. We must multiply with that e there. This e is going to be e to the power of negative st divided by, on the numerator, we have this 3s multiplied by that s there. This is going to give us 3s squared. There we go. But we are not done. We need to put this inside the brackets like that. Let's not forget our upper limit, it's infinity. The lower limit is 0. Now, let's simplify this one further. Let's do this. The first bracket is going to be for the upper limit, which is infinity. So let's simplify this e before we even write. Look at the e's there. These e's, they have the exponent, which is negative. So we can take the e's to the denominator, and then our exponent, they're going to be positive. So for the first term there, we're going to be left with 7, in fact, negative 7t divided by 3s e to the power of st. Remember, if the base goes to the denominator, the sign of the exponent changes. As you can see, st is no longer negative, it's now positive, right? Minus, we do exactly a similar thing there. On the second term, we're going to be left with 7 over 3s squared e to the power of st. There we go. So this is the bracket for the upper limit, minus by the same integral there, simplified as we did, of the lower limit. So it's going to be negative 7t divided by 3s e to the power of st minus 7. And then this time we have 3s squared e to the power of st. There we go, people. So basically, this is how you do this. Let us not forget the lower limit, which is 0. Right. So let's create some space again so that we can able to solve this. Right, people. So this is a very long question. You need to bear with us as we are solving this question. Now we can start substituting here. Let's substitute on the first bracket. If we substitute on the first bracket, we have negative 7. And then wherever there is t, we're going to substitute with upper limit, which is infinity, divide by, let's do this. We have 3, and then we have s, and we have e to the power of s. Wherever there is t, we're going to put infinity there, right? Minus, and then we have 7, divide by, we have 3, we have s squared, we have e to the power of s multiplied by infinity, close bracket. And then we are done with the first bracket of the upper limit, and then we move to the bracket of the lower limit. So let's look at it. We have negative 7, right? Wherever there is t, this time around, we substitute with 0, divide by 3s, then we have e to the power of s multiplied by 0, minus 7, divide by 3s squared e to the power of s multiplied by 0, and close bracket. Now, if you know about infinity, anything multiplied by infinity is going to be infinity. On the numerator, we have negative 7 multiplied by infinity is infinity. On the denominator, we have 3 multiplied by s multiplied by e to the power of s infinity. So this is going to give us infinity. Minus 7 divided by infinity. There we go. So this is how you're going to get this one on the other side. And then we say minus. And then on this bracket here, you'll be left with 0. Negative 7 multiplied by 0 is 0. Divide by 3s, because we have 3s e to the power of s to the power of 0. So e is going to become the power of 0. Anything to the power of 0, it's 1. So we multiply by everything. And then minus 7 divided by 3s squared. That's it. Then we close them. Now we have a challenge here, guys. If you can look at this one here, right? This one here is actually infinity over infinity. So the answer is going to be infinity. So what we need to do here, we need to use the L'Hopital's law in order for us to continue here. Only for the one that I highlighted, which is this one here, guys. So if you use the L'Hopital's law, let's continue. Let's see if it's possible, guys. Right, people, let's apply the L'Hopital on the side. So if we apply the L'Hopital on this one, we have to derive negative 7t. It's going to give us negative 7. Do you guys see? And then divide by. Now, if you look at the denominator, we are only deriving e to the power of st. So that's going to be s multiplied by e to the power of st ln e. But we already have s there, so this is going to be s squared, then e to the power of st. So this here, it's when we use L'Hopital on this one there. Instead, we're going to substitute this there. So let's do it underneath there. So we're going to have y is equaling to, let's do this, negative 7, right, divide by 3, right? And then what do we have there? We're going to have s squared e to the power of s. Instead of writing t, we're going to write infinity, minus 7 divided by infinity, right? We're going to continue later on. And then we have this one as well. We have 0 divided by 3s minus 7. And then we have 3s squared. And then we close the bracket there, right? So this, it's way too long if you decided to continue like this. But I had to explain how do we get to the answer. So obviously, this is going to be negative 7. Underneath them, we have e to the power of infinity. So this we're going to make everything underneath or on the denominator to be infinity. So we're going to have another 7 divided by infinity, and then we close the bracket there, and then we open the bracket. This one is still 0 divided by 3s minus 7, 3s squared. There we go. Now, if you don't know, guys, if you divide any number by infinity, the answer is going to be 0. Y is going to be equaling to. Now, let's look at the first bracket there. We have negative 7 divided by infinity. This is going to give us 0. We also have negative 7 divided by infinity. That is also 0 there. So the first bracket is useless. Now, let's look at the second bracket. We have 0 divided by 3s. That is going to be 0. And we're left with minus 7 3s squared. There we go. Let's create space. You'll be left with y is equaling to, the whole of this bracket is 0. So even if you don't write it, it's fine. Minus this minus here. And then we have 0. Even if you don't write it, we're fine. We'll be left with negative 7 over 3s squared. And then we multiply by minus. Our final answer is going to be positive 7 over 3s squared. So this is our final answer, guys. This was a very, very long question, but it doesn't have to be this long for you when you write the test, because some of the steps you don't really have to show them. I showed some of the steps because I wanted to clear out some confusion when you are watching this video. I hope this helped you to understand how to do the Laplace transformers. So after this, we will do question 5.2. But if it so happens that this question 5.1 help you to understand how to solve this type of problems, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. If you are stuck somewhere or you didn't understand at some point, go to that point, watch at the point where you did not understand. And if that doesn't help, leave a comment. I'll try to answer you to my level best. All right, people, we are done with 5.1. I hope you understood. Let's go and do 5.2. All right, guys, here's 5.2. If you have noticed from the introduction, 5.2, it has 4 sub-questions. But first, let's read the question of 5.2 there. Given it's x plus y is equaling to 1 and y is equaling to root of 1 minus x squared. Now, 5.2.1, they want us to calculate the coordinate of points of intersection. So these are two graphs. At some point, they interact with each other. So they're going to interact with each other. And those intersections, they have coordinates. First of all, let's write our two equations there. We have x plus y is equaling to 1. And the other one, we have y is equaling to root of 1 minus x squared. Now, this one here, we can call it 1 for now. And this one, we can call it 2. So in order for us to find the coordinates, we need to use simultaneous equation, and then we just substitute them. Now look at equation 2, already is equaling to 1. So we can substitute equation 2 into 1. Remember, equation 1 is x plus y, but instead of writing y, we're going to write this here because that is equaling to y. So we're going to write root 1 minus x squared, and all this is equaling to 1, right? So from here, we just have to transpose this x to the other side. On the left-hand side, we're going to be left with root of 1 minus x squared, and then on the right-hand side, we'll be having 1 minus x. Now, it's time for us to get rid of the root. So if you get rid of the root, you have to square both sides there. Let's square it. Now, this square and the root, they will give you the exponent of 1. And then on the left-hand side, we're going to be left with 1 minus x squared. Then on the right-hand side, we need to factorize this. So we can do the following. 1 multiplied by 1, it's 1. 1 multiplied by negative x multiplied by 2, this is going to give us negative 2x. And negative x multiplied by negative x, that's going to give us positive x squared. Guys, you can FOIL if you don't understand this method. From there, we can transpose the ones on the left and deal with the like terms. So we're going to be left with 0 here. Then we transpose x squared. So x squared is going to become positive. So we're going to have x squared plus another x squared there. And then we have minus 2x. And this one here is going to become positive, and the one on the left is going to become negative. Right, let me create space so that we can able to solve this further. Right, so on the left we're left with 0. We have like terms, we have x squared and x squared. When they add, they're going to give you 2x squared, and we also have negative 2x, and then we have 1 and minus 1. That is going to give us 0. So even if you don't write it, it's fine. So from here we can take out the common factor. Let's take out the common factor. We still have 0 here on the left hand side. The common factor is actually 2x. Then inside the bracket we're left with x minus 1. There we go. All right, so from here we can say 2x is equaling to 0, and x minus 1 is also equaling to 0. So if we divide by 2 both sides and this one here, we can transpose this negative 1 to the other side, becomes positive. Now let's create space here, guys. If you create a space here, we know that our x is going to be 0 and the other one is going to be positive 1. So we have these here. These are x coordinates for our intersections. Now let's find the y coordinates. In order for us to find the y coordinates, it's really not that difficult. Right, guys, I just created space. Let's use equation 2, which is y is equaling to root of 1 minus x squared. There we go. So wherever there is x, we're going to substitute with x values there. So when x is equaling to 0, you can say y is equaling to root of 1 minus x squared. But we're not going to write x squared, we're going to write 0 squared. So our final answer here is actually 1. So when x is 0, our y is 1. The first coordinate for the intersection, let's call it A, is going to be 0 and 1. There we go. Now, when x is 1, we're going to substitute it there. Y is equaling to root of 1 minus, wherever there is x, we substitute with 1 squared there. And this is going to give us the square root of 0. So meaning now, let's call this coordinate B. When x is 1, y is going to be 0. So this is how you do this one, guys. Yeah, I hope you managed to understand. All right, people, we are done. As you can see, this was not a difficult question. This is a grade 10 math. But just in case you got confused, you can go to the point where you got confused. You can leave a comment if rewatching it doesn't help. And if it really helped you to understand how to solve this type of a problem, don't forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Right, people, we are done with 5.2.1. Let's look at 5.2.2. All right, guys, let's look at 5.2.2. Now let's read the statement and let's solve it. The statement goes like this: make a neat sketch to show the enclosed area, the representative strip, and the point of intersection. So here they want us to draw the graph of these two functions here, or these two expressions. Now you need to able to identify what functions are those. Now when I look at the first one, we have x plus y is equaling to 1. If you make y subject to the formula, this is going to become y is equaling to negative x plus 1. Now this here, guys, is actually a straight line graph. So let's call this one y1. And then the other one is just y is equaling to root of 1 minus x squared. Now this one here, guys, it's actually a graph of semicircle, and is the upper semicircle, right? So let's first find the coordinates of this graph here. So I'm going to do it here. When x is equaling to 0, what is y, right? What is y? So we're going to substitute 0 where there is x on that formula there. So y, let's call it y1, is equaling to negative 0 plus 1. So basically y1 is equaling to 1, right? Then we are done. Now we can say when y is 0, what is x. Again, we are going to use the very same formula. Remember, we are looking for the point where we can able to draw our graph there. When y is 0, what is x? Wherever there is y, we substitute with 0, and then we have minus x plus 1. And then we transpose this x to the other side. Our x is going to be positive, and our x is going to be 1. So we have 2 points here. Let's call this one point A. When x is 0, y is 1. Let's call this one point B. When x is 1, y is 0. There we go. Now, let's look at this graph here. This graph, like I said, it's a semicircle graph. So if you don't know much about semicircle graphs, guys, this is N4 work. We know that the general formula for this is actually plus or minus, right? And then this is going to be r squared minus x squared, basically. So for the fact that we have a positive there for this one, it means now it's going to be a semicircle, which is going to intersect the y-axis because it's equaling to y. Now, remember, it means that our r squared is actually equaling to 1. So when you draw the circles, guys, or semicircles, what you need to find is the radius. So meaning radius, if we square root here, square root there, is going to be equaling to 1. So that's all we need to draw this graph here. So let's draw our Cartesian plane, and then we're going to draw our graphs here. All right, people, we are done with our Cartesian plane. Now let's look at point A, where we have 0 is x and y is 1. Now we all know that on our y-axis, x is 0. So our point A is going to be there where y is 1. And then let's look at point B, where our x is 1 and our y is 0. Now we also know that on our x-axis, our y is going to be 0, our x is going to be 1. So let's make it to be 1 there. So we have those 2 points, and then we can start connecting the dots and draw our graph. There we go, guys. So this is how the straight line graph looks like. Now it's time for us to name our graph here. Remember, this graph is a straight line graph, so we name it y1, which is equaling to negative x plus 1. There we go, guys. Now it's time for us to do the second graph. As you can see, the radius there, it's 1, and then we can start putting the points on y1, negative x1, and the other one, which is positive x1. And from there, we have to connect the dots. So let's connect the dots. Now our graph looks like this. As you can see, it's a semicircle on the upper part. So this here, they say we must find the area enclosed by the graph. So we must be very careful. They want the area that is enclosed by these two graphs, as you can see there, the green graph and the red graph there. So we need to highlight that. That's it, guys. So this is how it's supposed to look like, the area. Now that we have highlighted, it is time for us to find the next part of this, which is the representative strip there. So make sure that the representative strip is within the area that is highlighted. As you can see there, I'm doing it there, right? And don't forget to write change in X. There we go. So basically, this is what they wanted you guys to do. Do not forget that we have those points, so you can write the coordinates of these points. So let's do it. So we have the coordinate there at the top, which is gonna be 0 and 1. So let me write 0 and 1, and the other one is 1 and 0. So these coordinates, please show them before you continue with the next problem. All right, people, I hope we can able to draw this graph here. We are done with this. All right, people, if this part of the video helps you to understand, don't forget to like, share, subscribe, and comment as well. We are done with 5.2.2. We're going to do 5.2.3. Let's look at 5.2.3. Now, here they want us to calculate the magnitude of the area in question 5.2.2. The area that we highlighted in yellow there, that's what they want us to calculate. So from N4, we know that we can calculate this area using integration, especially definite integrals. Now, before you do that, I forgot to write this. We know that this here, we said it's y2. which is equaling to root 1 minus x squared there, right? So this is equation number 2. Now, in order for you to calculate the area, guys, there's a formula that you must use. So this is the formula. By the way, this is from definite integrals. So you have sigma and the upper limit and the lower limit there. And then you will have y2 minus y1. Now, it's not always y2 minus y1 here, guys. It depends on the graphs there and your naming of your graphs. So I'll explain that as we continue. Let me first explain the upper limit and the lower limit. How do you get them? First of all, if you are integrating with respect to x, in this case, as you can see, we have dx there. The upper limit and the lower limit, you have to take the x values of the intersect coordinate. If you still remember the intersect, here they are. So you only take the x values since we are integrating with respect to x. So the one that is bigger is going to be the upper limit, and the one that is lower is going to be the lower limit. Let's write our sigma there. The upper limit, if you look at the coordinate of the intercept there, the x value for this one here, it's 1. And for that one there, it's 0. So the one that is 1 is going to be the upper limit, and then the one that is 0 is going to be a lower limit. Remember, we took the x values of the intercept coordinate, right? Let me explain why am I writing y2 minus y1. Now let's look at the area there, the one that I highlighted in yellow in our graph. Now, if you look at these two graphs there, they form that area there. The one in green, it's actually on top of the area. We named it y2. So it's the one that's supposed to be positive. And then the red graph, which is y1 there, is going to be the one that is subtracting because of the following. It's underneath the area that we highlighted. So you always do it that way. So let's substitute the actual equations of these y's. So y2, we know that it is the root of 1 minus x squared, while minus y1, it's negative x plus 1. Then we close the bracket, then we close another bracket, then we have dx. So let's look at this. Now, what we have here, we have to simplify first. So let's simplify. So let's rewrite it as 1 minus x squared under the square root there. And then we multiply by negative. This x is going to be positive, and the 1 is going to be negative there. And then we close the bracket, and we have a dx. As for x minus 1, we can able to integrate that one. But as for the root of 1 minus x squared, we have to manipulate this in a way that we can able to integrate. So let me create space here, guys, so that we can able to do this one. Let me first do this. All right, we can say let sine theta equaling to x. So in other words, if we derive this, let's find the derivative of this, guys. We're going to derive sine theta equaling to x using implicit. Okay, so if we derive sine theta, this is going to be cos theta. Since we are doing implicit, this is going to be multiplied by d theta over dx. There we go. And then the derivative of x is going to be 1. There we go. So if we can make dx subject to the formula, so this is going to be as follows. Dx is equaling to, we cross multiply there, it's going to be cos theta multiplied by d theta. There we go. So this is from this when we make dx subject of the formula. So bear in mind when it comes to this. Then another thing that you should know, if we decide to make theta subject to the formula from this equation here, we can do the following. We can say theta is equaling to, if we transpose this sign to the other side, we're going to have arc sine x. There we go, right? So we have to separate these derivatives. So let's separate them. So we have the following, 1 upper limit, and then the lower limit is 0. So this one here, we can say the root of 1 minus x, but we said x is equaling to sine theta. So we can say minus sine theta squared, because this is x squared. And then instead of writing dx, we can write dx in terms of cos theta and then multiply by d theta. So let's write it as cos theta multiplied by d theta. Right. So like I said, we have to separate this so that we don't get confused. Plus, now we're going to do this separately. We have the sigma 1 upper limit, 0 lower limit, x there. This one is still with respect to x for now. And then the last one, we have minus sigma upper limit, lower limit, and then that is going to be 1. And also this one is with respect to x. So the one that we're going to focus on a lot is this one here, guys, which is this part there. I hope you guys understand. By the way, if you don't understand, leave a comment or rewatch at the point I didn't understand. So let's continue. Now, if you continue here, remember 1 minus sine squared theta could be written as cos squared theta. Let's put a bracket here. I forgot the bracket. Right, so let's do it. So we can write the sigma upper limit 1, lower limit 0. So under the root, we can write as cos squared theta, because we know that cos squared theta is the same as 1 minus sine squared theta from the square identity. So let's continue. Let us not forget that we also have multiple of cos theta multiplied by d theta. So we can put this inside the bracket again. Right, plus, so this one, we're just going to drop them for now so that we don't get confused. We have sigma upper limit 1, lower limit 0, x and dx multiplied by dx minus sigma upper limit 1, lower limit 0, 1 dx. There we go. So we just separate this, guys. Please don't get confused. I'm going to do it step by step. Now look at this one here. Let me highlight with red again. Look at this one here. We have cos squared under the square root. So we can rewrite this as the following, guys. Let's do it. We can say sigma upper limit 1, lower limit 0. We have cos theta, because the square root of cos squared theta is actually cos. But let's not forget, we have this cos again. So we're going to multiply by that cos again. And then close bracket, d theta. Plus this one, we drop them as they are, guys. We drop them as they are. Then dx minus sigma 1, 0, 1 dx. Right. I hope you guys are still with me. Let me create space here. So we can multiply cos and cos theta. Sigma 1 upper limit, 0 lower limit. Now we have cos squared theta. And then we have a d theta there. As for these ones, we drop them, guys. Let's drop these ones as they are for now, right? Let's drop them. Let's not integrate it differently. Let's integrate everything at the same time. So from here, we know that there is a special identity that we can use. Sigma, the upper limit is 0. Cos squared theta, you can also write it as, let me just do this, half, right, plus cos 2 theta divided by 2. And then we have d theta. This here, guys, let me highlight it again. This can be replaced by that. This is a special identity, guys. So I hope you know about it. And it's also there on your formula sheet, just in case you're not so sure. So let's continue. And then these ones, we keep on dropping them as they are, right? Let's drop these terms as they are. We are not integrating it, right? Let's do it. So let's continue. Now we can able to integrate each term here. So let's integrate the terms. So let's start with the first one here. If we integrate here, we're going to have area is equaling to. So what is the integral of half with respect to theta? It's going to be 1 over 2 theta, right? And then plus. Now we need to integrate cos 2 theta over 2. So this is going to be sine 2 theta over 4. And then we have the upper limit again, which is 1 and 0. So meaning we have to integrate the second term. The second term is x. So the integral of x is going to be x squared divided by 2. and then the limit is still 1 and 0, and then minus, and then the integral of 1. The integral of 1, guys, is just x, because we are integrating with respect to x for this one, and then the limit here is still 1 and 0. There we go. So from here, people, we can start, or we can try to replace these. But before we replace them, we have to fix the following. We have 1 over 2 pi, right? Then we say plus, then we can use this double angle identity, which is 2 sine theta multiplied by cos theta divided by 4, right? There we go. And then we know that we have the upper limit, which is 1 and 0. And this one, again, we're just going to drop it for now. We don't do anything at the moment. And then we know that the upper limit and the lower limit, the upper limit is 1, the lower limit is 0, minus x, which also has the same limit, 1 and 0. Right, so let's create space here. Now, when you look at the first one there, we need to replace theta. If you still remember at the beginning, we said if sine theta is equaling to x, so theta is equaling to arc sine x, right? So we can write as 1 over 2. But instead of writing theta, we can write arc sine x. What we are doing here, basically, we are changing back to x, by the way. So plus, we have 2 sine theta multiplied by cos theta. So we have 2, but 2 and 4. So this is going to give us 1 over 2. So sine theta is the same as x, remember. So this is going to be x multiplied by cos theta. Now, remember, we can take it from here. Cos squared theta plus sine squared theta is equaling to 1, right? If you make cos squared theta, substitute the formula, we're going to have 1 minus sine squared theta. And then if you square root there, right, square root there, cos theta is going to be equaling to the root of 1 minus sine squared theta. So instead of writing this, we can write it as 1 minus sine squared theta. But what is sine theta? Sine theta, we said it's x, so you can write this as x squared. I hope you guys can see. Divide by 2 there. Remember, there's 2 here and the 4, they divided each other and they gave you half. And then there we have the upper limit, which is 1, and the lower limit, which is 0. Plus, then these ones, we're just going to drop them as they are. I hope you guys can still see this. I hope you can still see this. Then we have that minus x, and then the upper limit is 1 and the lower limit is 0. So when it's like this, you can start substituting now. Now our area, let's start with the first bracket. We can see the first bracket, we're gonna write everything. So we're gonna write half, right? Arc sine x plus x root 1 minus x squared divided by 2, right? Plus, this time around, let's just do this. X squared divided by 2 minus x. Then this here is the bracket for the upper limit, which is 1 minus everything similar to this. Again, these are definite integrals, guys. So please remember, from N4, this is how we do it. So we have half, we have arc sine x plus x root 1 minus x squared. All this is divided by, there we go. Let me create a little bit of space here. In fact, let me zoom down. I hope you would see, guys. Zooming down. There we go. And then we have plus x squared divided by 2 minus x. And then here, the upper limit is 0. Guys, don't forget these limits here. These limits are the same as these guys here, guys, right? I hope you can see. I just decided to put everything inside one bracket. So let's continue. Now let's start substituting. I'm going to do it here, right? Area is going to be equaling to open bracket. We have 1 over 2 arc sine, and then instead of writing x, we're going to substitute with 1 plus we have x, then we're going to write 1 there, and then we have root of 1 minus x squared. This is going to be 1 squared inside the bracket, divide by 2, plus, instead of writing x squared, we're going to write 1 squared divided by 2 minus 1. And then this is the upper limit, minus. Now we're going to do the same thing here. We're going to have half, and then we're going to say arc sine. Instead of writing x on this one, we're going to write 0 because this is the bracket for the lower limit, plus, and then 0 wherever there is x, root of 1 minus 0 squared, and then we divide by 2, plus x squared, but in this case it's going to be 0 squared divided by 2 minus 0, and then we close the bracket. Guys, I hope you can still see. Let me create space here so that we can solve this further. Right, if we press our calculator here, the first term inside here, we have half arc sine 1. That is actually 90 multiplied by half. That is going to give us 45 degrees. Do not forget, this is degrees, plus, now this one here, we have 1 root of 1 minus 1 divided by 2. This here is going to give us 0. And then we go to the third term. That is going to be 1 to the power of 2 divided by 2. That is actually half minus 1. There we go. And then, so on this one here, 1 over 2 arc sine 0, it's actually 0. And then the second term, we have 0 multiplied by root of 1 minus 0 divided by 2. That is 0 because it multiplies by 0. On the fourth term here, we have 0 squared divided by 2. That is going to be 0 minus 0. So basically, the last bracket, it's actually 0. So if you look at these here, we have 45 degrees and we have half minus 1. So your answer is going to be 45 degrees minus half. Now, rather change this into rads. The right way of doing this is to change 45 into rads so that it can interact with negative half. So when you change that into rads, it's 45 degrees, right, multiplied by pi over 180, and then minus half there. So this here, let me just put it inside the bracket. This here is gonna give you pi over 4 minus 1 over 2. There we go. So with this, you can now use a calculator. You can get your final answer. So our final answer is actually 0.285 unit square. Guys, this was very long and it was challenging. I have to be honest with you, this was very challenging, but this is how you do this one, guys. Just in case you didn't understand, go to the point where you did not understand and rewatch it. But this was the question and this is how you're supposed to do this one. I hope you understood though. If this question helped you to understand how to solve exactly this type of a question, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. Guys, we are done with 5.2.3. We're going to do 5.2.4. Alright guys, here is question 5.2.4. This question here, they want us to calculate the volume of the solid of revolution formed when the area in question 5.2.2 is rotating about the x-axis. When it is rotating on the x-axis, guys, there's the formula that you must use. Volume is equaling to pi, right? And then we have sigma. Again, here we're going to write the upper limit, right? And then here we're going to write the lower limit. And then we're going to have y2, but this time we square it, minus y1. And then we square it as well. And then dx. If they say it rotates about the x-axis, we mean that you must have dx there. Remember, our y2 is actually the green graph, or the one with root of 1 minus x squared. And y1 is the straight line graph, the red one, or the one with minus x plus 1. So let's just substitute there. If we substitute, let me substitute here, right? Remember, we said volume is equaling to pi, and then we have sigma there. The upper limit here it's 1, it didn't change. The lower limit is still 0. But inside there, we're going to have y2 squared. So remember our y2 is the green graph there, which is root of 1 minus x squared. Then we have squared there minus y1 squared. Remember, y1 is negative x plus 1, and then let's not forget we square it there. And then dx. When you say dx, it means it rotates about the x-axis. So let's continue. Let me create space here so that you can able to solve this problem there. Now, if we continue like this, we can say volume is equaling to pi. Now we have our sigma again. Our upper limit is 1, our lower limit is 0. And then we have to simplify this. Look, the first equation there, we have the root of 2 and squared. They're going to give you the power of 1. So you're left with 1 minus x squared. And then we close there. We say minus. And then this one here, we have negative x plus 1. All this, they have the power of 2. You can simplify this by multiplying negative x with negative x. It's going to give you positive x squared. Multiply negative x with 1 and multiply it with this 2 there. It's going to give you negative 2x, and then 1 multiplied by 1. This is going to give you 1 like this. And then we have dx there. So we need to simplify it further. Let's remove the brackets. So volume is going to be pi, and then sigma, upper limit 1, lower limit 0. And then this one here, you can write it as 1 minus x squared. There's nothing we can do there, but we need to remove this bracket there. So we're going to have x squared plus 2x minus 1 dx. Then we'll have like terms here. I hope you can see, guys, this x squared and that x squared, they are like terms. We have 1 and negative 1. They are also like terms. So if we continue here, let's continue there. We're going to have volume is equaling to pi, right? Upper limit 1 and lower limit is 0. So inside there, we're going to have negative 2x squared, because we have 2 negative x squared there. I hope you can see them. And then we say plus 2x. As for 1 and negative 1, they're going to give you 0. Then from here, we start integrating this one. So let me create space so that we can integrate these ones here. Right. So v is equaling to pi. Let's integrate now. Inside the bracket, we need to integrate negative 2 x squared. So this is going to be negative 2x squared plus 1 divided by 2 plus 1. Remember, this is a standard integral. Plus, we have 2x to the power of 1 plus 1 divided by 1 plus 1. And then we have the upper limit, which is 1, and the lower limit, which is 0 there. If we continue, we're going to have volume. We have pi there. And then let's simplify everything there. We have negative 2x to the power of 3 divided by 3. And then here we're going to have plus 2x to the power of 2 divided by 2. And then we have the upper limit and the lower limit there. So let's rewrite them in a way that we can able to substitute. So we have v, which is our volume, is equaling to pi. And then the first bracket is for the upper limit, which is going to be negative 2x cubed divided by 3. And then we have 2 and 2, they divide each other. We're left with x squared here. And then we close there. This is going to be for the upper limit, then minus. And then here it's going to be pi as well. Remember, this pi is affecting everything. And then we have negative 2x to the power of 3 divided by 3 plus x squared. And then the lower limit here is 0. And the next step here is v is equaling to pi. Now we start substituting. On this bracket, we're going to substitute with negative 2 multiplied by 1 to the power of 3 divided by 3 plus. And then this one here is going to be 1 to the power of 2. Remember, wherever there is x, we substitute with 1 minus. Then we have pi here. And then wherever there's x on this bracket, we substitute with 0. We're going to have negative 2. And then 0 to the power of 3 divided by 3 plus x squared, but we're going to make it to be 0 squared and then close the bracket. Remember, guys, the second bracket is for the lower limit. Let's create space here. Now we have v is equaling to pi. So inside here, we have the following 1 over 3. in close bracket, and then this on the other side we have pi, and everything inside there is actually 0. So if we continue, the final answer, our volume is gonna be pi over 3 unit cubed, or you can say 0,106 unit cubed. This is how you calculate the volume of these equations there. I hope you guys managed to understand this. Again, if it so happened that you did not understand, you can always leave a comment on the comment section where you got lost, and I'll try to help you to my level best. But if this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Guys, we are done with 5.2.4. Now we're going to do the last question of this question 5, which is going to be 5.3. All right, guys, here is our question 5.3. Now let's read the statement and let's analyze it so that you can be able to solve the problem. So the question goes like this: calculate the moment of inertia of a circular lamina of a radius r and the mass m about an axis through its center and perpendicular to the plane of the lamina. So basically what is happening here, it's a disk that we have to calculate the moment of inertia. This disk here, it has a smaller disk, so we need to find the area of that disk, and we can able to calculate the inertia of that disk. So we have 3 planes here. We have the z-axis, we have the y and the x-axis. So basically the disk looks like this. So you're gonna have a disk like this. There we go. And then obviously it's the center. So the smaller disk that you're gonna have is gonna be something like this. Then we have this small portion here of the disk is the one that is being actually known as the change. So this small disk here, we're gonna work on it. Now from here we have 2 radius, guys. We have the inner radius, which is for the smaller disk, and then we have the outer radius, which is for the bigger disk. That's right, R there with the big R. With this, we can able to use our knowledge about the circles and the area of the disk. So we have an outer disk, which is the outer disk. There we go. Now there's things that you need to know about the outer disk. First of all, the area of the outer disk, we write it as pi bigger R squared. So make sure that it's R with capital letter so that you can know that this is for the outer disk. And then we have density as well. So the density for this disk is actually density, and then we have a mass, and then we divide by the area of the disk. So from here we can make m subject of the formula, the mass of the disk. So this m is going to be density multiplied by area. We just cross multiply. Now let's look at the smaller disk now. This is the smaller disk here, the one with the red radius there, right? So let's do it smaller disk. There we go. Now the information on the smaller disk, we also have the area, which is pi small letter r squared. So we can derive this area so that we can find the area of the smaller ring there, the one that we highlighted in black there. So if we derive this dA over dr, we're going to have the following: 2 pi r. So this is a change in area. So that is the area of the ring that we highlighted in black there. So if you make dA subject to the formula, we're going to have 2 pi r multiplied by dr. There we go. So from here, we're going to find the change in mass. So it's going to be dm over dA. And then this is going to give us the density there, right? So if we make dm subject to the formula, it's going to be density multiplied by change in area there. There we go. Now, before we continue, we can also equate this density with mass over pi big letter area squared. Let's not forget that. All right, so from here, So let's create a little bit of space here because we need to substitute. We can say dm is the same as density multiplied by, so instead of writing dA, remember this is dA there. We're going to substitute that dA there with 2 pi r multiplied by dr. There we go. Now, this is very important because we're going to substitute this on our formula. Let's go to the formula sheet and let's select the right formula to calculate the moment of inertia. Here is our formula. Guys, let me highlight it. This is the formula that we can use to calculate the inertia of the entire disk. So let's do it. Now, here's the formula there. I is equaling to sigma. So this is the moment of the inertia of the entire disk. So we have to include big letter R there and 0. If you still remember from our disk, the whole disk, the radius is going to be from the center to the whole of the disk. So that's why we use big R there. And then it's R squared multiplied by dm. But if you still remember, dm, it's this here. So we can substitute dm there. So let's do it. Sigma, big letter R, and then we have 0 there because it's starting from 0. So we can substitute our dm. We have R squared there. So our dm is density multiplied by 2 pi r multiplied by dr. So here we'll be actually integrating with respect to r because we have dr there. All right, so let's continue. Let me create a little bit of space here. Now, if you continue here, we know that we can take out the coefficient outside the sigma. Let's take out 2 pi and the density, and we will be left with, inside the sigma there, we'll be left with r multiplied by r. That will give us r cubed. So that's going to be r cubed dr. Now, when it's like this, we can able to integrate. So let's integrate. When you integrate here, this is going to be 2 pi and then density multiplied by the following. The integral of this is going to be 3 plus 1 divided by 3 plus 1. And then we close there. We have r, the bigger radius, and 0. All right. So let's continue. And then if you continue, this is going to give us 2 pi. Let's change our density into m divided by pi r squared. Remember, the density include the radius of the outer disk or the bigger disk. So here we're going to have inside there, we're going to have r to the power of 4 divided by 4. Okay, let us not forget the upper limit and the lower limit. Remember, the upper limit is the radius of the bigger disk, and the lower limit is the 0 point there, or the center, which is 0. All right, so before we continue though, we have pi and pi. So we actually left with 2m r squared. Now that we substitute the smaller r with the bigger r, remember the outer is the bigger r. So it's going to be r to the power of 4 divided by 4 there. Then you can leave it like this because the other bracket of the lower limit is going to give you 0 anyway. So let's create some space again. Now I is going to be the following. Let's not forget we have r squared and r to the power of 4 there, and we have 2 divided by 4. We'll be left with mr squared divided by 2. So here, this is our final answer, guys. Right, this is how they wanted us to do this question. I hope you understood, guys. If you didn't understand, don't forget to watch at the point where you didn't understand. Then you can always leave a comment in the comment section and I'll try to answer you to my level best. Guys, we are done with question 5. We are going to do question 6. All right, people, here is our question 6. Now, as you can see, question 6, it has only 2 questions and it is also based on differential equation. So we'll start with question 6.1. We're going to solve it and then we do 6.2 later on. So let's create some space and let's do this question here, which is 6.1. All right, here is our 6.1, guys. So let's read the question and let's solve it. The question goes like this: determine the particular solution of dy over dx is equaling to 3 over cos squared x if x is equaling to 45 degrees and y is equaling to 2. So like I said earlier, this is a differential equation and this is actually the first order. So first of all, here we need to group these term here. Any term that has y, it should be with dy, and any term that has x, it should be multiplied by dx. So what you're going to do here, we're going to cross multiply. So let's rewrite our equation. There we have dy over dx, which is equaling to 3 over y cos squared x. There we go. So if we cross multiply here, dy is going to be multiplied by y, which is going to be equaling to, we have 3 over cos squared x. When you cross multiply, we're going to have to be multiplied by a dx. Now look at the right hand side here. We have 3 over cos squared x. So we need to deal with 1 over cos squared there. Remember, 1 over cos is the same as sec x because that is an inverse. So let's simplify it further. So we're going to continue here and write dy multiplied by y. And then we have 3, the coefficient. We just said that 1 over cos squared is going to give us sec squared x multiplied by dx. Remember, these are inverses. Just in case you don't know much about inverses, you can go to the description. I'll leave the video on inverses, and also the very same video will pop up at the top right of the video that you're watching at the current moment. Now let's continue. Now that we have managed to group this, we can introduce the sigma both side. Now we can able to integrate with respect to x and with respect to y for both sides. Now let's continue and integrate. Now the integral of y on our left hand side is as follows. It's going to be y to the power of 1 plus 1 divided by 1 plus 1 equaling 2. And then the one on the right here, we have the coefficient of 3, and then we have to integrate sec squared. If you still remember, sec squared is a derivative of tan. So when you integrate sec squared, it's going to give us tan x, right, plus c. There we go. Let's continue and simplify it further. Let me create a space here for a minute. So on the left hand side, we have y squared divided by 2. And then on the right hand side, we have 3 tan x plus c. Right, so when it's like this, we can cross multiply and let's make y squared subject of the formula. If you cross multiply, we have to multiply by 2 through and through there. So let's multiply by 2. So y squared is going to be equaling to, if you multiply by 2 here, we're going to have 6 tan x plus 2c. Right. Remember, we are given the values here. Remember, x is equaling to 45 degrees, while y is equaling to 2. Now we can substitute these values for x and y so that we can get our c there. Right, let's do it. So wherever there is y, we're going to substitute with 2 to the power of 2. And then we have 6 tan. Instead of writing x, we're going to write 45 plus 2c. So this means that we can find the value of c. So on the left hand side, we have 2 to the power of 2. That is going to give us 4. And then we have 6 tan 45. This is going to be 6 tan 45. It's actually 1 plus 2c. There we go. Now let's find the value of c. We have to transpose this 6 to the left hand side. We're going to have negative 6 plus 4 equaling to 2c. Right, let's create space again so that we can able to solve this. Right, so if you continue, this here is going to give us negative 2 equaling to 2c there. So if we divide by 2 throughout, negative 1 is going to be our answer for c. So we can say c is equal to negative 1. Right, now that we are done with this, we can substitute back the value of c to get the actual equation. Then let's go back and let's see what was the actual equation before we find c. So if you look at this step here, we can substitute our c there. So let's do it. So I'm going to do it here. So y squared is going to be equaling to 6 tan x plus 2c. But instead of writing c, we're going to write -1 like this. So let's work it out. So we have y squared is equaling to 6 tan x minus 2. So we have to make y subject to the formula. So we have to square root both sides there. So if you square here, y and square root is going to be equaling to y there. And meaning our y is going to be equaling to 6 tan x minus 2. So this here, guys, is our final answer. Right. I hope you managed to understand this, guys. I don't find it to be difficult. But if you got lost somewhere, please do not forget to watch at the point where you got lost. Or if that doesn't help you, you can always leave a comment on the comment section. If this part of the video managed to help you to understand how to solve such problems, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. All right, people, we are done with 6.1. Let's do 6.2. All right, guys, here is our 6.2. Now, 6.2, it goes like this. Determine the general solution of cos x d squared y over dx squared is equaling to sine 2x plus 2 to the power of 3x multiplied by cos x. So here they want us to find the general solution. So as you can see, we have the second derivative here. So this is a differential equation, but second order. We need to first make d squared y over dx squared subject of the formula. So when we do that, we need to divide by cos x, because this d squared y divided by dx squared is multiplied by cos. So let's do it. So we have cos x multiplied by d squared y divided by dx squared. And then this must be divided by cos this side. And this is going to be equaling to same thing here. We have sine 2x. Guys, sine 2x is a double angle identity. For sine, we can write it like 2 sine x multiplied by cos x there. Let's not forget, we also have to divide this by cos x. There we go. Plus, and then we have 2 to the power of 3x multiplied by cos x. And also this, we have to divide by cos x as well. So what we did here, we divided by cos x through and through. So what you do on the left-hand side, you must also do on the right-hand side. As for this one here, that is a double angle identity for sine. Just in case you don't know about double angle identities, I'm going to leave a link or a video on the description that is about these double angle identities. Go to that description and click on that video if you want to learn about the double angle identities. And the very same video will pop up on the top right of the video that you're watching at the current moment. So let's continue. Now, if you continue, you know that this cos and that cos, when they divide, you'll be left with d squared y over dx squared. And then on the right hand side, we have cos and cos. They want to divide each other. On the first term on the right hand side, you're going to be left with 2 sine x plus, and then the last term here also have cos and cos. They will divide each other, and you're going to be left with 2 to the power of 3x. There we go. So from this, we can start integrating. So we're going to introduce sigma both sides here. Now that we managed to introduce sigma, let's create space and let's integrate. Now, the integral of d squared y over dx squared is just going to be dy over dx, right? And then as for the ones on the right-hand side, we have to integrate each term there. We have to integrate 2 sine x first. So we know that 2 is a coefficient, and then the integral of sine x is going to be negative cos x. There we go. Plus, now we have to integrate 2 to the power of 3x. This here is an exponential integral. So when you integrate this, it's going to be 2 to the power of 3x divided by 3 ln 2 plus c. So let's simplify it further. dy over dx is equal to negative 2 cos x plus 2 to the power of 3x divided by 3 ln 2 plus c. There we go. So we can call this one C1 because we are not done. Now that we are finished with the first integral, we need to do the second integral. So you have to introduce sigma again here for both sides as well, right? Let's put this inside the bracket like that. So when you integrate the left-hand side, which is dy over dx, the integral is going to be y. There we go. And then on the right-hand side, we have to integrate each and every term there. Now let's look at negative 2 cos x. So when you integrate cos, it's going to be sine. But let's not forget the coefficient is negative 2 there. The integral of cos is actually sine x. And then plus, we have 2 to the power of 3x divided by 3 ln 2 plus c1. So let's do the second term. So the second term is going to be 2 to the power of 3x divided by 3 ln 2. And then we have to multiply with another 3 ln 2. There we go. Remember, this is the 3 ln 2 from the first integral. Now that we are doing the second integral, it's going to be, again, 3 ln 2 on the denominator. Plus, now this C1 is actually a constant. Remember, when you integrate the constant, we just multiply by the variable we are integrating with respect to. In this case, x is actually that variable. So this is going to be C1 multiplied by x plus C2, because we have to also include C2, the constant for the second integration. So let's simplify this, and then we have our final answer. So when we simplify this, y is actually going to be equaling to negative 2 sine x plus 2 to the power of 3x divided by, let's open bracket, 3 ln 2, then we square it, plus c1x plus c2. So here, this is our final answer, guys. I hope you guys managed to get this one as well. If you did not manage to get it, go to the point where you got lost, rewatch at that point. If that doesn't help, do not forget to leave a comment in the comment section, and I'll try to answer your question to my level best. If this part of the video helped you to understand, guys, do not forget to like, share, comment, subscribe to the channel if you haven't subscribed. Guys, we are done with question 6, and also we are done with the whole question paper. I hope these videos help you to understand how to solve this type of problems that are being asked on this question paper. Thank you very much, guys, for watching. Till next time, cheers.